You might think high-tech telescopes let us see every inch of the moon, but that's not true. At our satellite's south pole lie giant craters untouched by sunlight for eons, stuck in pitch black, colder than Pluto, and almost impossible to explore. However, maybe we have to if we want to explore space. Because the darkness hides some must-have resources that will make life and long-distance travel in space possible. Yes, we're talking about water locked up as tiny crystals in the lunar soil. Now, water in space is always good news. You've probably heard that scientists are also obsessed with finding it on Mars. If the red planet has any type of water below its surface, it raises the exciting possibility that life might have existed there. Even microbes would be the biggest discovery in human history. That's why rovers are poking around Martian craters and drilling into the soil like some very dedicated space gardeners. But as incredible as water on Mars would be, water on the Moon might be even more valuable to us in the short term. The reasons are simple: the distance and the gravity of the Moon. We can reach our satellite in 3 days. That's almost nothing. It takes at least 7 days to reach New York from London via a cruise ship. But more important than the length of the trip is the possibility of using the Moon as a pit stop. Stop, refuel, and relaunch so we can resume exploration. The gravity on the Moon is only 1/6 as strong as Earth's. That's not just useful for endlessly entertaining yourself by jumping around. This difference means that launching rockets from our satellite is much easier compared to launching them from Earth, which requires a tremendous amount of fuel just to break free from the atmosphere. For example, the Saturn V rocket, which took astronauts to the Moon during the Apollo missions, was made up of more than 90% fuel just to get off the ground. On the Moon, however, it's much easier to launch a rocket. That means that we could carry heavier loads with less fuel. It's like being able to take a bigger suitcase on your trip. If we can find and use ice on the Moon to create rocket fuel, it would turn our satellite into a practical and affordable stop for exploring the solar system. Not to mention that by applying some basic chemistry, we could extract oxygen from water and use it for breathing or rocket engines. Also, astronauts would need water to drink and grow crops on the lunar base. So, what do we know about the latest discoveries? For a long time, scientists thought the Moon was completely dry. But in 2009, NASA basically crashed a rocket into a crater. It caused an explosion of ice and vapor, like fireworks, and finally confirmed that the Moon had some kind of water. But how much? Well, enough to matter. The data suggests there could be hundreds of millions of tons of water ice locked up in the Moon's polar regions. Some estimates roughly say 1.3 trillion pounds. That's about the same weight as 460 million cars. Not exactly lakes, but still a lot. And there still could be more. This water could also contribute to uncovering cool scientific secrets. The ice is ancient, which makes it like a time capsule from the early days of the solar system. Studying those frozen molecules might tell us not only how water got to the Moon, but also how it appeared on Earth. Anyway, what's all that water doing on the Moon? How did it get there? Scientists assume that some of it probably hitched a ride on comets and asteroids billions of years ago. Many of those space rocks carried ice, and some of that water ended up in the polar regions. Another source could be the way solar wind interacts with the lunar surface. In any case, however this ice appeared on the Moon, the real trick is where it ended up, inside its polar craters. And while we can find the ice not only in the craters at the South Pole, that's where the largest, most stable reserves are believed to be. Some of those craters are enormous. One of the most famous is called the Shackleton crater, and it's over 13 miles wide and more than 2 miles deep. That's almost twice as deep as the Grand Canyon. The Moon barely tilts on its axis, only about 1 degree, so the sun never peaks over the rims of those deep polar pits. The temperatures dip to around -400 degrees Fahrenheit there. Any water or chemicals trapped in that frozen dirt just stay there, locked away like in a freezer. Something really cool is that at the South Pole, you have parts that are stuck in the perpetual darkness. But some nearby mountain ridges get almost non-stop sunlight. Scientists call them the peaks of eternal light. They are perfect for setting up solar panels, while still being close enough to access the icy treasures hidden below. The poles of the moon are the only places in our solar system we know of where perpetual day and night exist side by side. But the eternal night isn't just fascinating, it's dangerous. The terrain out there is absolutely unforgiving. We can't even simulate something like that on Earth. We don't even know what it looks like from the inside. It's worse than exploring the northernmost part of Antarctica while wearing a blindfold. So now that we know this, is that potential water even obtainable? That question is probably worth several trillions of dollars. Yes, there's water over there, but getting to it won't be like scooping ice cream from a bowl. What we're really talking about are microscopic ice crystals mixed into lunar dust. To make use of it, machines would need to dig and heat up the soil, then capture the vapor before it escapes back into space. And then there's freezing. Even assuming a human or rover could safely reach the bottom of a crater, it'd be almost impossible to navigate. Batteries and equipment probably wouldn't last, and it's impossible to use solar panels or electronics down there. They'd freeze in minutes. However, NASA's Lunar Reconnaissance Orbiter uses all kinds of radars and sensors to sniff out what the crater looks like inside. And now there's an even sharper tool, Shadow Cam. A camera so sensitive it can capture details in light 100 times dimmer than what our eyes can see. Basically, the ultimate night vision device. With it, we can finally map those pits without even setting foot there. That's why engineers are thinking up all sorts of clever solutions. Some concepts involve nuclear-powered rovers with headlights strong enough to carve through the dark. Others want robots that rappel down crater walls or hop across the floor like pogo sticks. There are even ideas for drills that could melt frozen soil and trap water vapor like condensation on a cold soda can. The silver lining is that this water isn't going anywhere. Until we improve our technology, the supply will wait for us. That being said, space agencies are already making advancements. In fact, more than half a dozen new missions are lined up over the next few years. NASA's Artemis program is getting ready to send astronauts back around the moon and then down to the South Pole. China's Chang'e 7 is planning to check out those dark craters. And private companies like Firefly and Blue Origin are gearing up to deliver equipment and experiments. Now, here's a bonus, lesser-known fun fact. The moon smells. When Apollo astronauts brought lunar dust into their landers, it mixed with the oxygen inside and ended up smelling pretty strong. They said it was like burnt gunpowder or fireworks. Lunar dust has nothing to do with gunpowder, but its particles are highly reactive. After sitting in space for billions of years, they reacted instantly with oxygen in the cabin, creating that smoky odor. Future explorers are definitely going to notice that smell too, since lunar dust tends to stick to everything. Let's hope that, aside from everything else, scientists will work out air fresheners for the moon base. Soon we might start constructing loads of stuff on the moon. All because India's moon mission has recently detected sulfur near the moon's south pole. This chemical element can come in extremely handy for creating infrastructure on our satellite. It's the first time this chemical element has been discovered on Earth's natural satellite. This sought-after element is mostly found near Earth's volcanoes. Its appearance on the moon speaks volumes about the satellite's volcanic history and its past atmospheric conditions. The mission's rover detected this chemical element less than a week after touching down around 70 degrees from the moon's south pole on the 23rd of August, 2023. This historic landing on the lunar surface made India the fourth country to safely land a mission on the moon. It's also the first spacecraft to touch down so close to the south pole of our satellite. It's an area of strategic importance because it's believed to be home to deposits of water ice. If it turns out to be true, future missions might be able to harvest it and turn this water ice into drinking water or even rocket fuel. For 2 weeks, the lander carried out the data collection, mainly focused on the analysis of the moon's soil and its extremely thin atmosphere. Meanwhile, the solar-powered Progyan rover started its quest to find frozen water on the moon. As for the lander, it demonstrated another amazing feat on the 3rd of September. The spacecraft fired up its engines and lifted itself for about 16 inches into the air. Then it made a tiny hop to land 12 to 16 inches away from its original position. It's kinda a big deal. Being able to get a lander back off the surface of the moon is essentially for future missions, showing that they can safely return soil samples or even astronauts back home after a lunar mission. In September, the Indian spacecraft was put into sleeping mode. The 14-day-long lunar night was approaching, and the spacecraft wasn't designed to collect scientific data during this period of time. So far, we've learned about a few major findings of the mission. One is related to measuring the temperature of the moon's topsoil at different depths. Intriguingly, the surface of the satellite in that region turned out to be hotter than expected. It was believed that the temperature could be between 68 and 86 degrees Fahrenheit on the surface, but it was around 158 degrees Fahrenheit, way hotter than it should be. The other discovery indicates the presence of several chemical elements, including oxygen. Besides, the data received from the spacecraft confirms the presence of aluminum, calcium, iron, titanium, silicon, and other chemical elements on the lunar surface close to the South Pole. The rover also used special instruments designed to measure quakes and rumbles beneath the lunar surface to detect some seismic activity. It brings us back to the sulfur detected thanks to the rover's spectroscope. Scientists are currently working on figuring out whether this element formed on the surface in a natural way or whether it's the result of volcanic activity or a meteor strike. Another astonishing thing found on the moon is a rock, and it may be the oldest known Earth rock. A 0.7-inch wide chip included in a large rock collection brought to our planet by Apollo astronauts might actually be a 4-billion-year-old fragment of Earth. This finding could help us paint a better picture of the intense pounding early Earth got at the dawn of its life. It could go like this. Soon after the rock formed, an asteroid impact might have blasted it from Earth. At that time, our planet's satellite was 3 times closer to Earth than it is today. The collision was so powerful that this chunk of terrestrial rock found its way to the moon. Later, this fragment got engulfed in a lunar breccia, a motley kind of rock. Eventually, the rock was brought back home to Earth by Apollo 14 astronauts. Even though scientists had found meteorites coming from Mars and the moon before, it was the first time a rock from the moon turned out to be a terrestrial meteorite. They also found out that the rock had formed in a water-rich environment at temperatures and pressures corresponding to those at around 12 miles beneath the surface of our planet. In 2019, China's Chang'e 4 mission made history by landing on the far side of the moon. The mission's rover helped researchers visualize structures hidden deep below the surface of the satellite, revealing billions of years of lunar history. The Yutu-2 rover made this discovery with the help of its lunar-penetrating radar. It imaged deep into the moon's surface and listened to echoes of sound bouncing back off structures hidden from view under the surface of the moon. It turned out those structures were resting at depths of almost 1,000 feet. The research suggests that the first 130 feet under the surface are made up of layers of dust, soil, and rocks. The instruments also discovered a concealed crater that must have formed after a large object slammed into the moon's surface. Long, long ago, ancient lava was likely to be flowing deep underground. Researchers believe that the broken rocks around the formation might be debris produced by the impact. They also found that the volcanic rock layers were thinner the closer they were to the surface. Such a thickness variation of lava flows might mean a decrease in the number and magnitude of eruptions over time. So, lunar volcanic activity gradually dwindled since the moon's formation around 4.5 billion years ago. On the far side of the moon, there is one of the largest and oldest impact craters in our solar system, the South Pole Aitken Basin. Unfortunately, from Earth, you can only see its outer rim, which looks like a huge chain of mountains. It's a ginormous 8-mile deep dent, stretching for more than 1,500 miles in diameter and covering 1/4 of the moon's surface. Astronomers are sure that this crater appeared when an asteroid collided with the moon around 4 billion years ago. And now, look at this gigantic chunk of metal the size of 4 states of Connecticut. As for its weight in pounds, it's enough to say that the number contains 18 zeros. This mysterious mass is hidden about 180 miles under the moon's surface, somewhere in the middle of the South Pole Aitken Basin. It was discovered when GRAIL, which stands for NASA's Gravity Recovery and Interior Laboratory Mission, gathered data about our natural satellite. When examining this information, scientists noticed that in one place on the moon's surface, there was a weird change in gravity. After researching this phenomenon, they concluded that something mysterious was weighing down the basin floor there. So far, researchers haven't figured out the origin of the bizarre lump, but there are several theories. One of them claims that the finding is a chunk of dense oxide, which appeared when the moon was just taking its shape. At that time, the satellite was still covered with ancient oceans of magma, and the lump could be formed at the final stages of its cooling. However, most scientists support another theory, according to which the puzzling mass is part of the giant asteroid that once created the South Pole Aitken Basin. Since the thing is metallic, it's probably the iron-nickel core of the asteroid. There might be a labyrinth of lava tubes on the moon. Not so long ago, astronomers received the results of underground topography and discovered a massive cave under the surface of Earth's satellite. It could be the result of the lunar volcanic activity that happened more than 3 billion years ago. Streams of lava hardened, creating a thick, hard crust on the outside. But inside, it kept flowing, melting the rock and creating tunnels and caves. Numerous small pits in the moon's surface discovered by NASA seem to be the openings to such lava tubes. If this theory is confirmed, the underground tunnels might serve not only as a convenient location for human-crewed space missions, but also as much-needed water sources for astronauts.
It's been decades since the last manned moon landing, Apollo 17, which happened in December 1972. Isn't it time we thought about going back to our dusty satellite, and maybe even staying there? NASA has made a promise on this subject. They're preparing to send astronauts on the moon again, perhaps by 2025. This will all happen through a program called Artemis. It's also going to include the first woman ever to experience the lunar surface. Now you might ask, why haven't we done this already? One former NASA administrator said something interesting on the subject. It's not because of scientific or technological issues. Problem was that the potential projects took too long and were just too costly. You see, space travel, especially when it involves humans, isn't easy on the pockets. It's true that, in recent years, NASA had budgets of billions of dollars. Sure sounds like enough money, right? Well, not when you check out their to-do list. That's because they have to consider everything. From telescopes and giant rocket projects to missions also targeting the Sun, Jupiter, Mars, and beyond. When you look at it this way, NASA needs to be very good at budgeting to achieve all those goals. It's not just because of finances, though. The moon itself is quite problematic. It poses real dangers that cannot be taken lightly. For starters, its surface is filled with craters and boulders that aren't easy to land on. Then, there is the moon dust, or regolith, if you'd like to call it by its scientific name. It was created over many years by meteorite impacts. It's extremely harsh and sticks to everything. It can potentially damage spacesuits, vehicles, and systems quite quickly. Also, dealing with the lunar habitat isn't a walk in the park either. The moon has no protective atmosphere. What this means is that for 14 days at a time, the lunar surface is faced with harsh rays from the sun. That period is followed by another 2 weeks of total darkness. All these changes create extreme temperatures, which us humans are not really accustomed to. There are solutions, don't worry. NASA is working on dust and sun-resistant spacesuits and vehicles. They're even developing a system that might supply electricity during those lunar nights. What's even more interesting about this system is it could come in handy on Mars too, once we get there. NASA also needs to draw in really smart people for its projects. Think about it. The average age of the people working for the mission control for Apollo 13 was just 26 years old. And these people had already been part of numerous missions by that time, which means they'd had considerable experience from a very young age. But here's where other individuals can help too. In recent years, it wasn't just NASA who's been working tirelessly to revolutionize space travel. There are many successful people out there with enough resources to join in on these efforts. Some are developing new types of rockets that can land on the moon too. In total, NASA landed 12 people on our satellite. It's definitely one of the most awesome moments in its history, if not the best. And those astronauts did amazing things up there. They brought back rocks, took snapshots, did science experiments, and even left flags behind. These were all important moments of the Apollo missions, but they weren't meant to create a safe place for humans on the moon. Scientists have had this idea of a lunar space station for a long time now. It's only logical. After all, it's just a 3-day trip from Earth. It means we can, technically, afford to make little mistakes here and there, without messing up the whole project. Plus, we'd learn so much before venturing even further into space. A moon base could provide fuel for deep space missions. We could also build telescopes up there and launch them way easier in space. It could also help us in another important project: figure out how to make Mars habitable too. Not to mention, a lunar space station would help us learn more about the moon's origin. Who knows, it could even bring in some money because of all that fun, exciting lunar tourism. Either way, the Apollo moon program took a lot of work. For starters, let's look at the sheer number of people involved. Around 400,000, from every corner of the states. Not everything was picture perfect, tough. There were two main unfortunate events. Firstly, a fire mishap at the launch pad of Apollo 1. Secondly, an oxygen tank decided to throw a tantrum on Apollo 13, causing severe issues mid-mission. An important part of the project was Saturn V. It is to this day the most powerful rocket flown successfully, being 36 stories high. Still finding it hard to picture? This rocket stood twice as tall as Niagara Falls. Thanks to Saturn V, NASA successfully completed 13 missions. This included chauffeuring 24 astronauts towards the moon, with half of them even having a little walk on its surface. The existing rockets and space shuttles can't go beyond low Earth orbit. In simpler terms, they can't reach the moon with all the gadgets astronauts need to thrive. Current space vehicles are just not capable of carrying that load, at least not since the Apollo missions happened. Regardless, we did make a lot of progress on Earth and are ready to send astronauts to our satellite pretty soon. Here's where the Artemis project comes in. It's a program overseen by NASA. And to make sure it all goes well, NASA previously launched Orion, a spacecraft with no crew on board to orbit the moon and return to Earth. Think of it as an automated test drive. Before we actually send people out there again, we need to make sure all the devices work properly. One day, Orion will be the vehicle that will take astronauts to the moon again. It features a launch abort system to keep astronauts safe in case something bad happens during launch. It also has a service module, which is the powerhouse that fuels and propels Orion and keeps astronauts alive with water, oxygen, power, and temperature control. All these future projects make one wonder, what will life on the moon be like anyway? We can only use our imagination for now. Some say we'll be living in homes straight out of a fairy tale, something like a cozy hobbit hole. Living underground on the moon might be a must. That's due to the scorching temperatures and the lack of oxygen. If you add meteorite threats and the non-stop radiation, it's no wonder we can't just walk on its surface. What about transportation? Big and small companies alike are trying to create the ideal moon ride. If current estimations are current, one type of moon taxi will take off as soon as 2024. Unlike our current rockets, these space taxis won't have to deal with the harsh conditions of re-entering Earth's atmosphere. It will be easier for them to make multiple round trips. To support our lunar living, we'll need to have a special area for space taxis to safely take off and land. Think of it as a landing pad on a firm, flat stretch of moon surface, protected by walls to shield against moon dust. Moving around on the moon's surface will be made easier too. The next generation vehicles we're talking about will have their own controlled environment, which means you won't need a spacesuit while inside. Should feel like stepping out of your space ride for a bit. Then of course, you'll need to put on your spacesuit. All right. So we've got our homes and our rides sorted. But what about fuel? That's where the moon throws us a lifeline. The moon's lighter gravity means we don't need as much power to escape its pull. Plus, the moon has ice, and that's super handy. We might be able to convert this ice into rocket fuel. We'll need dedicated space gadgets to help gather this ice. One such tool is called Trident. It's like a drill, perfect for digging into the icy moon surface. Additional robotic helpers would then turn this ice into fuel and deliver it to a space gas station. If this works, rockets on their way to Mars could stop by for a quick fuel top-up before continuing their journey.
It's so close to us, at least in terms of space, but there's still so much we don't know about the moon yet. For example, Chinese researchers have collected soil samples from the moon and found out there might be billions of tiny glass spheres on the lunar surface. What's really cool is that they might hold enormous amounts of water. These tiny spheres form when meteorites hit the moon at crazy speeds, sometimes at hundreds of thousands of miles per hour. When that happens, a strong explosion sends bits of the moon's crust flying into the air like popcorn. As these chunks of crust cool down, they create little glass beads that look like tiny glittering spheres. These beads are so small that they're like crumbs sprinkled over the moon's surface. Scientists call them impact glass. And it turns out the soil on the moon is holding a secret ingredient that can make water, oxygen. So, these tiny glass balls are like little capsules with oxygen inside. There's a special type of wind called solar wind, and it's made of protons and electrons. When protons hit the capsules, they mix with the oxygen inside and finally make water. But the most amazing part is that some of these glass balls with water inside get hidden under a layer of the moon's dust called regolith. So if we go on a mission to the moon, we'll have hidden reservoirs of water underground. It's as if someone has prepared some canned food for us to survive. Because you can't drink that water directly from these glass beads, you're supposed to collect them and then boil them in an oven to extract the water. When they cool, they release vapor, so you'll have regular liquid water in a bottle. That way, astronauts on their missions will be able to stay longer up there, considering these secret stashes. And the coolest thing is that these glass beads are very common on the moon. They're spread from the poles to the equator, which means there might be enough water even for generations that might come to live there one day. There are other spots where we can find water in space too. For example, scientists found an extremely big cloud of water vapor that's 12 billion light years away from us. Not within reach, of course, but it's still good to know. And we're talking about something bigger than we can imagine. It's thought the cloud contains at least 140 trillion times the amount of water in all the oceans and seas on our home planet. Imagine swimming or scuba diving there. It's like taking a dip in a giant water balloon that's traveling through space. I mean, you wouldn't have a way out considering the amount of water in there, but hey, at least the view would be magnificent. Water is actually everywhere across our solar system. It's mostly in the shape of atmospheric gas or ice, and sometimes even in its liquid form. And there are probably many water worlds in our galaxy too. Scientists from the University of Copenhagen have discovered exciting new evidence about how planets form in our solar system and beyond. Their computer models have confirmed the interesting theory of pebble accretion, which means that planets form from tiny pieces of ice and dust. This theory is based on the observation of disks around young stars that are made up of pebbles that come in several hundred Earth masses. As these pebbles collide and clump together, they form protoplanets and, eventually, planets. What's even more exciting is water could be an important ingredient in this planet's making. It also means that the water may not have come to Earth by chance, for instance, via icy comets hitting our home planet. Instead, maybe it was there from the very beginning. Perhaps planets in our neighborhood, like Mars and Venus, formed with water as well. Scientists also say we shouldn't assume we're a special case just because we have water. There could be many planets all over our Milky Way galaxy as big as Earth that have water too. That means there could be many worlds in our galaxy with continents and oceans, which could also mean there is a great deal of life out there waiting to be discovered. But just because there's water somewhere, it doesn't mean that place would be a good spot for an interstellar summer vacation for future generations. Water on many planets is probably embedded in rock or fills underground oceans. Researchers have checked more than 40 exoplanets we know about. They're all smaller than Neptune and located around something we call red dwarf stars. These make up 80% of all stars we're familiar with in our galaxy. They're cooler than our Sun and also the smallest type of hydrogen-burning stars. And there could be more planets with enormous amounts of water than we thought. Plus, this water can take up to half of the total mass of these planets. Scientists know this because they've been studying the density of these exoplanets. They have realized they're too light to be made entirely out of rock. I've mentioned Venus before. Today, it's a hot, rocky planet a bit smaller than Earth, with a dry atmosphere and only some traces of water vapor. It's also very poor in oxygen. But in its early stages, the planet may have been a completely different world with liquid water and even clouds, which means it's possible there used to be life. What if Venus used to be similar to Earth, with oceans and moderate temperatures? It would be great if it stayed that way, because these seem like good conditions to develop life, so we'd probably be writing letters to some of our space friends from there, or visiting them already. But the scenario went in a different direction for Venus about 700 million years ago or so. The planet got so hot it lost all of its oxygen. That's why it wasn't able to form liquid water on its surface. Instead, it developed a thick atmosphere made up of carbon dioxide, which made this world even hotter than Mercury, even though it's twice as far from the Sun. Even icy comets pelting it couldn't bring water back to its surface. We can't do it either in some artificial way. It would be like trying to grow a delicate flower in a desert. No matter how much you water it, if the conditions are too dry and harsh, the flower won't survive. But some people thought the water in the atmosphere of our close neighbor could be enough for developing life. Plus, scientists have discovered there is a compound called phosphine that's often associated with living organisms on Earth. Maybe in the past this was enough. Today, the amount of water on Venus is so small, even our toughest microbes that are extremely tolerant to droughts wouldn't be able to stay alive there. Phosphine is still a cool discovery worth investigating, but not something that tells us there could be life on Venus. Jupiter might be a more likely option for that. The Galileo probe flew through the atmosphere of this magnificent gas giant to measure the temperature and water activity. It found out there was enough water for life to exist in the planet's clouds, but sadly, there are not enough nutrients there. Plus, there's too much ultraviolet radiation, so most organisms wouldn't actually be able to survive there. And everyone knows Europa, one of Jupiter's moons. It's that very place in our solar system that has the biggest chances to support life. Its icy crust probably hides an ocean underneath. And because of Jupiter's gravity that affects Europa, the ocean is not frozen, but remains liquid. The ocean might be warm under that icy crust, probably thanks to hydrothermal vents. Enceladus, one of Saturn's moons, probably has even higher chances to host life than Europa. And it's one of the best candidates to have a beautiful, warm, and salty ocean beneath the surface. It has the coolest ice geysers that catapult into space about 1,000 tons of water every hour, together with salt, organic molecules, and some other materials.
Neil Armstrong had been getting ready for his mission on the moon for over 3 years. To resist microgravity conditions, he had to learn how to walk sideways by being strapped and suspended at an angle in trying to walk along walls. His limits were tested through an intense diet and sleep regimen, since in space he would only have beef and vegetables, previously dehydrated and stuffed into a package. Back in the day, astronauts had to experience the desert, jungle, open sea, and Arctic survival training. These days it's a lot more structured. But back then, it was more of a let's drop this person in the middle of nowhere with no supplies and see if they make it. Before landing on the moon, he had to gather and study rock samples in the Grand Canyon, explore ancient volcano formations in the Nevada National Security Site, and look into gas and lava vents, lava lakes, and pit craters in various locations in Hawaii. On July 20th, 1969, Armstrong was given a hearty breakfast before blastoff. Steak, eggs, toast, juice, and coffee. He received what doctors call a low-residue meal, which means he wouldn't have to go to the bathroom soon after. It took him 109 hours and 42 minutes to reach the surface of the moon, in an area called the Sea of Tranquility. He had to travel 240,000 miles to get there. The crew could have gone for the Ocean of Storms or the Central Bay, but this place was chosen for landing because it had good visibility, was relatively smooth, and was easily reachable with as little propellant as possible. When he was at about 500 feet above the surface of the moon, Armstrong had to maneuver the spacecraft manually to make sure they wouldn't land in a dangerous crater. He continued to hover for about a minute and a half, moving it sideways until he felt comfortable to land. As soon as his device landed safely, he immediately radioed to Mission Control, located in Houston, Texas. The now famous message,
"The Eagle has landed."
Steadily, he went down the lunar's module's ladder, while a television camera was attached to the craft to record his progress. The camera also transmitted the signal back to Earth, where hundreds of millions of people were anxiously waiting. At precisely 10:56 p.m. EDT on the same day, Armstrong placed his feet onto the lunar soil, saying,
"It's one small step for man, one giant leap for mankind.
The schedule said that the astronaut needed to sleep before the first moonwalk, but he chose to go outside earlier than planned, since he obviously couldn't sleep. If Armstrong had walked on the moon without special equipment to breathe, he would have smelled a weird odor, sort of musty and sulfuric. Still, he had the chance to smell it when he returned to the lunar module. The thing is, the dirt had clung to his feet, so the odor spread all over the cabin. He described it as wet fireplace ashes, or how the air smells after fireworks shows. Who would have thought you needed to pack a scented candle when going to the moon? Apart from the people that have since made it to the moon, no one ever got the chance to know precisely what the crew was smelling. Even during that first mission, when moon soil and rock samples were transported to labs in airtight containers, once they were opened back on Earth, surprisingly, the smell was gone. He also felt the surface of the moon to be fine and powdery, but said he had no difficulty in moving around. One other member of his crew joined him about 20 minutes later. The whole moonwalk took a little over 2 hours. During this time, Armstrong and his teammates set up various devices on the surface of our satellite. One was meant to precisely measure the exact distance from there to Earth, by timing how long it took for a laser beam to travel from Earth to the lunar surface and back. Another meant to measure moonquakes and potential meteor impacts, which leads us to the discovery that the moon was pretty alive after all. We know today that the largest moonquakes are much weaker than the largest earthquakes, though their movements can last for up to an hour, way longer than on Earth. They managed to gather somewhere around 50 pounds of rock and soil samples. They also snapped many photographs of the terrain, where they also planted a US flag. The astronaut even got the chance to catch up with President Richard Nixon, for less than a minute though. The final thing on the list for Armstrong was to go for a walk to what is now known as East Crater, 65 yards east of the lunar module. It was the greatest distance traveled from the spacecraft on that specific mission, approximately the length of half a football field. As soon as his tasks were done, Armstrong went back into the lunar module and safely closed the hatch to get some sleep. While preparing for liftoff, Armstrong and his crew discovered that, because of their chunky spacesuits, they managed to break the ignition switch for the ascent engine. No big deal, they thought. So they used a part of a pen to push in the circuit breaker to start the launch sequence. At 1:54 p.m., the famous Eagle began to ascend. Apart from the scientific equipment installed on the surface of the moon, a plaque was also left there. It read, "Here, men from the planet Earth first set foot upon the moon, July 1969 AD. We came in peace for all mankind." Years later, Armstrong said that NASA limited their time on the moon because they didn't know how the spacesuits would handle the moon's extreme temperatures, as high as 260 degrees Fahrenheit during the day, to as low as 280 degrees Fahrenheit below zero at night. Things got a bit more complicated when Armstrong landed back on Earth, since he had been exposed to unknown space particles. The result? He and his team had to be placed in planetary protection quarantine on their return, as soon as their space capsule safely splashed down in the Pacific Ocean on July 24th. That specific quarantine for the Apollo 11 astronauts is one of the reasons why we have microwaves in our kitchens today. When they first returned from the moon, they initially spent their first few days in a mobile quarantine facility, or MQF. Sure, the MQF featured comfortable chairs, bunks, a toilet, and showers, but it didn't leave a lot of space for fancy cooking. Since there was no room for a standard oven or grill, and to also reduce the potential fires that might have occurred, NASA had to get creative. That's how the original countertop microwave oven was developed, to easily help astronauts get their meals without the hustle of a fully equipped kitchen. These days, you can see that first microwave in a museum in Oakland, California. After returning to Earth, Armstrong claimed he would never reach for the stars again. But he didn't stop exploring though. Back in 1985, he joined a professional team of other greatest explorers to the North Pole. He was joined by mountaineer Edmund Hillary, aviator Steve Fawcett, and photographer Patrick Morrow, reaching the pole on April 6, 1985. Armstrong claimed he wanted to see what the Earth's icy pole looked like from the ground, since he had only seen it from the surface of the Moon. The Apollo 11 mission was nevertheless unforgettable for Armstrong since. In 2015, the Smithsonian Institution uncovered that he had kept hidden a cloth bag full of small parts from the lunar module. It included his waist tether, some utility lights and their brackets, an emergency wrench, and the optical sight that was mounted above Armstrong's window of the space module. It also contained the data acquisition camera that recorded the iconic footage of Armstrong taking his small step on the Moon. Armstrong kept it to himself for many years, until his widow Carol eventually found it. He even kept it a secret from his official biographer, who at many times asked if he had kept any memorabilia from his famous mission. He didn't sneak those objects back on Earth, though. He just mentioned it to be a bunch of trash he wanted to bring back.
There's something happening inside the Moon, something that nobody expected. Not a dramatic shift you'd see on the outside, but deep down, where things seem frozen in time, scientists have uncovered a hidden layer of what you could only call moon goo. Remember those school lessons about the crust, mantle, and core? Much like the Earth, the Moon is made up of layers, a crust, mantle, and core. However, the Moon's core is much smaller compared to ours. Earth's core is huge. It makes up about a third of our entire planet's mass. The Moon's core makes up only about 1 to 2% of its mass, and its diameter is about 1/5 the diameter of the Moon itself. It's surrounded by a hard, rocky mantle. But it turns out that between these two layers, that mysterious goo layer, and it's way more important than you might think. The layer is soft and partially molten, ebbing and flowing like the tides in our oceans. It rises and falls, stretching and shifting as if it were alive. Its movement isn't chaotic, but subtle and regular. We always knew that the Moon influences our seas and oceans, causing tides with its gravity. But it turns out that we influence it back. The goo ocean reacts to the gravitational dance between Earth and the Sun. Also, the molten layer could be made of ilmenite, a very intriguing material. Ilmenite is rich in titanium, a strong and lightweight metal that we really love over here on Earth. Titanium is used in everything from airplane parts and spacecraft to medical devices, even in everyday items like bikes and laptops, all because it's incredibly strong and very resistant to corrosion and heat. So, if the Moon might have a molten layer rich in ilmenite, that would be awesome. Astronomers are already planning for lunar bases, and if we had a material to build structures, spacecraft, or even tools for astronauts right there, that would be a game changer. Otherwise, we'd need to transport materials from Earth, which is extremely costly. This is our first tangible sign that the Moon is not just a cold, boring rock. Instead, it's dynamic, living, and breathing, with moving forces beneath the surface. NASA used new special tools to discover this: the Gravity Recovery and Interior Laboratory and the Lunar Reconnaissance Orbiter. These are both space missions designed to study the Moon, but they don't just look at the surface like a telescope. Instead, they help measure things we can't see with our eyes, like the Moon's gravity and how it changes over time. Grail sent 2 small spacecraft around the Moon named Ebb and Flow. Clever. The idea was for these spacecraft to fly close to each other and measure tiny differences in the Moon's gravity as they go. It's like they were feeling the Moon's invisible pull in different places. If the Moon's gravity was stronger in one spot, the spacecraft moved closer together, and if it was weaker, they moved farther apart. This helps scientists understand what's going on inside the Moon, even if they can't actually go there. And the spacecraft intentionally crashed into the Moon in December 2012 to end the mission. The Lunar Reconnaissance Orbiter is a bit different. It takes super detailed pictures of the Moon and collects other important information about its surface. By combining the information from both GRAIL and LRO, we were able to find this goo layer. But this discovery actually challenges everything we thought we knew about lunar geology. How did this molten layer get there? How long has it existed? And perhaps more fascinating, how it stayed warm for millions of years? That's some million-dollar questions. The moon's core generates heat just like ours. But it's not as easy as saying, oh, the core's heat probably keeps it warm and molten. Well, first, the moon's core is much smaller and less active than Earth's, meaning it produces significantly less heat. Plus, the moon is much cooler than Earth in general. With temperature dropping to minus 200 degrees Fahrenheit on the surface, how could this inner layer still stay in this flowing state? That's still a mystery. In any case, this goo could actually explain a lot of stuff about the moon. For example, astronomers were exploring moonquakes and how they happen. Now they think that it might be this semi-molten layer shifting and moving beneath the surface. Now, beyond the moon itself, it also tells us more about other celestial bodies. If the moon, something we considered basically a huge static rock, has such a dramatic life, what about other planets, moons, or asteroids? Could they also hide similar hidden movements beneath their surfaces? We can even understand our own planet better, learn more about how tides and similar stuff works. There are so many great discoveries we've been making on the moon. Recently, we found some awesome stuff beneath the surface, massive caves hidden for millions of years. For over 50 years, scientists have suspected that the moon's surface is full of underground tunnels and caves. These are known as lava tubes because they were formed by lava. Duh! Millions of years ago, the moon was pretty unstable. It underwent some volcanic activity, causing eruptions. When a volcano erupts, lava can flow across the surface. As the outer layer of the lava cools and hardens, it forms a solid roof of dark material. It's actually what these famous dark spots on the moon are. These are dark, hardened remains of ancient lava. But the hot, molten lava continues to flow through the center. Once the eruption ends and the lava drains away, what's left behind is an empty hollow tunnel, hence a lava tube. On Earth, we have lava tubes in places like Hawaii or Iceland, where volcanic activity has created similar underground tunnels. The same thing happened on the moon billions of years ago, although they're much crazier compared to ours. In fact, lunar lava tubes are now thought to be some of the largest and longest in the entire solar system. One such cave was discovered beneath the famous Mare Tranquilitas, the place where Apollo 11 first landed, and it's at least 340 feet deep. Now, all these lava systems have remained hidden just beneath the surface, untouched for millions of years. Only now, they finally managed to prove their existence. Scientists from the University of Trento in Italy found them using special radar technology and advanced computer methods. These techniques let you see underground by sending radar waves. The waves bounce back and give clues about what's hidden underneath. By analyzing the way these waves reflected back, the researchers could detect the shape and size of the hidden caves. Now, the best thing about this discovery is that we could build all our bases there. These caves protect from radiation, harsh winds, and meteoroids. NASA even found evidence that some of these caves stay at a steady 63 degrees Fahrenheit. That's some crazy coziness for the moon. And on top of that, there could even be some water there. So humans could take shelter inside these natural tunnels and build entire colonies on the moon. And I know what you're thinking. Could unexpected lunar monsters hide deep in those caves? Well, sure. There's a huge potential for exploring these caves and finding some awesome stuff. But even if we manage to find a miracle, like small life or microbial organisms, there's a 99% chance that there won't be actual animals or monsters. It would just be impossible for them to develop in such conditions. But it would make a great horror movie. Researchers want to send robots or drones to explore the tunnels first, and then see if they're safe enough for humans. And it's not just the US getting in on the action. China is also investigating the possibility of using these moon caves as a future base, showing that the race to explore and settle the moon is heating up.
It's one small step for man, one giant leap for mankind.
is one of the most famous quotes of all time. But was it really what Neil Armstrong uttered on July 20th, 1969, as he set foot on the moon for the first time in human history? It looks like it both is and is not. Thousands of people back on Earth who were following the historical event heard the phrase without one small detail, the indefinite article, a.
It's one small step for man.
There's no such thing as small details when it comes to grammar, and the absence of a slightly changed the meaning of the whole sentence, since man and mankind became synonyms in that case. It basically meant, that's one small step for mankind, one giant leap for mankind. Neil Armstrong himself told the press after the Apollo 11 mission that there definitely was an A there, but people just didn't hear it. 30 years later, at the event's anniversary, Armstrong couldn't hear the article while listening to the recording of that famous transmission.
It's one small step for man.
He explained that he wasn't the most articulate person, and he left a lot of syllables out. So it could have been a suppressed sound, and the voice mic simply failed to pick it up. But he insisted that A had been intended, as without it, the statement wouldn't have made sense. In 2006, a computer programmer backed up Armstrong's words with some digital magic.
It's one small step for man.
He ran the audio through some software that singles out nerve impulses and saw it in the graphic form of sound waves. It became obvious that there was a 35 millisecond long bump of sound between for and man. It was too brief for other humans to hear, but Neil clearly did leave room for an A. Several years later, Ohio State University studied the speaking patterns of Central Ohioans, like the first man on the moon, and noticed that they often leave out words like for and A. In a BBC documentary, Armstrong's younger brother Dean mentioned that he had seen the quote written on a piece of paper months before the mission. Whether it really happened or not remains a mystery because he had never mentioned it before the documentary. Like with many famous quotes, people tried to find some symbolism behind Armstrong's words. One of his biographers suggested that the quote was inspired by the astronaut's love for J.R.R. Tolkien's books. There was a similar line in The Hobbit. Not a great leap for a man, but a leap in the dark. He found that connection because Armstrong had a Tolkien-themed email address in the 90s, and after retiring from NASA, moved with his family to a farm dubbed Rivendell. It was also the name of a valley and the home of Elrond, the half-human, half-elf from Lord of the Rings. Armstrong himself denied that connection since he hadn't read any of Tolkien's books before going on the Apollo 11 mission to the moon. Others believe the quote was based on the NASA memo. Going to the moon was no walk in the park, so it was important that the first person there pronounces some iconic words about it being a historic step forward for all mankind. Again, the astronaut denied having any memo. He later shared that it had just been the most logical and right thing to say. Armstrong literally had to go a long way to make that legendary step. He took his first airplane ride at the age of 6 in a Ford tri-motor plane with his father, and that's when he fell in love with aviation. He was an active Boy Scout and earned the highest possible rank, Eagle Scout. On his 16th birthday, he became a licensed student pilot before he got his driver's license. He then went on to study aeronautical engineering. His program involved 2 years of university studies at Purdue University, then leave for 2 years of flight training and 1 year of aviator service before returning to finish his final 2 years. While at Purdue, Armstrong joined a fraternity and wrote and directed a musical for the school varsity varieties. He was investing so much effort in his version of Snow White and the Seven Dwarfs that he got a C that term. In psychology for engineers, a C in aircraft vibrations, and a D in electrical engineering. During his aviator service, Armstrong had to eject from the plane over the water. The winds were taking his parachute back to land. When he thought that was it, His friend from flight school in a service vehicle picked him up and saved his life. Armstrong came back to Purdue, completed his degree, got married for the first time, and became a civilian research pilot right after. The couple moved to California, and whenever he flew over their house, Neil would tip the wings for his wife and son on the ground to see it was him. He had over 1,100 flight hours testing various supersonic planes and the X-15 rocket plane. He wasn't able to apply when the U.S. Air Force was recruiting for the first Man in Space Soonest program in 1958 because they didn't accept civilian test pilots. In April 1962, NASA accepted applicants again for Project Gemini, and this time he was eligible. Neil handed in his application past the deadline, so it was only thanks to a flight simulator who had known him and slipped the application in the pile that he got into the space program. Back then, he wasn't considered NASA's #1 pilot and flew as a backup crew. In 1966, Armstrong became the first American civilian in space, and together with David Scott, pulled off the first manual space docking maneuver. And that's where things have gone wrong. After docking, a rocket thruster had a meltdown and the spacecraft started spinning uncontrollably. They had to separate from the Agena. Armstrong took back control of the Gemini spacecraft, and they managed to perform an epic emergency splashdown in the Pacific Ocean. Then, it was time to choose who was going to become the first human on the moon. It had to be a civilian, and the decision makers at NASA chose Armstrong for that honor. Some people believed it was because he had a likable personality, quiet confidence, and was working hard on the way to the stars, literally. To prepare the astronauts for landing the lunar module and the reduced gravity they'd experience, NASA ordered practice vehicles to be built. In early May 1968, at just 98 feet above the ground, Armstrong's vehicle started rolling without control. He had to act quickly and eject to save himself. Later analysis proved that if he had done it just half a second later, that would have been his final moments. On July 16, 1969, Armstrong, along with other members of the mission, took off for the moon. NASA built the Saturn V, the most powerful rocket that had ever flown successfully, to take them there. It was as tall as a 36-story building. 4 days later, they reached their goal. After spending 21 hours and 36 minutes there, leaving their footprints, which are still visible on the moon's surface, collecting surface samples, taking photos, and testing scientific instruments, and headed back to Earth. Armstrong didn't enjoy public attention that much, so he decided to take up a teaching career. He became famous worldwide, but he still had to work hard to defend his master's thesis at the University of Southern California. He then retired from NASA and moved back to Ohio with his family, where he would teach for the following 8 years. He didn't cut the connections with NASA altogether and worked with them on several commissions, helping the investigations into both the Apollo 13 malfunction and the tragic Challenger space shuttle incident. In 1985, Armstrong journeyed to the North Pole with a group of fellow explorers. It made perfect sense that he wanted to see it not only from space, but from the ground level. For his giant leap for mankind, Armstrong was awarded the Presidential Medal of Freedom, the Congressional Space Medal of Honor, and the Congressional Gold Medal.
Hey, does anyone remember the gold rush? Back in the 19th century, prospectors were flooding California rivers with a pan in hand, chasing wealth. Well, scientists now say it might be time for the moon rush, because apparently precious metals worth over $1 trillion could be hiding underneath the surface of the moon. That's a lot of money. However, can we really reach it? And if so, who does it belong to? If you have ever paid close attention to the pictures of the moon, you probably noticed a lot of holes and craters. Our satellite is like a giant Swiss cheese. It has over 1.3 million craters. if you count those larger than 0.6 miles. But today, we're focusing on about 6,500 really big ones, those over 12 miles wide. Those were not made by little green men or little green moles, but rather by asteroids crashing into the moon since eternity. Scientists compared moon scans to meteorites, and after crunching the numbers, they think there could be a fortune in platinum hiding in those craters. What's exciting is that many of these resources could be just a few feet beneath the surface. The moon doesn't have an atmosphere like Earth, so there's no wind, rain, or earthquakes messing things up. That means those asteroid crashes left their priceless metals pretty much right where they landed, undisturbed in lunar dust for millions of years. With each crater like a giant space bowl catching platinum, iridium, palladium, and other metals. On Earth, we have to drill super deep just to get a tiny bit of these. By the way, did you know that most of the mineable gold on Earth likely came from ancient meteorites? When Earth first formed, almost all the original gold sank into the core. The stuff we can actually dig up today is probably what's left when space rocks slammed into the crust billions of years ago. So maybe you wonder why not reach for the asteroids and mine there? Well, that's because they're out of reach. Yes, in theory, it would be possible to mine from asteroids, but obviously the moon is way closer and easier to get to than any other giant rocks floating in space. We've already walked on it and brought back pieces of it to Earth, so it's fair to say we are familiar with it. This makes mining it a much smarter step than chasing unpredictable asteroids. However, asteroids are next on the list. Also, when it comes to mining the moon, it's not just about the prize. Some of those craters have frozen water. We know that because several missions, like NASA's Lunar Reconnaissance Orbiter and India's Chandrayaan-1, have found frozen water ice in dark craters near the moon's poles. This ice is super valuable because it can be broken down into oxygen and hydrogen. They are the parts needed to make rocket fuel. It could also be purified for astronauts to drink, or even used to help grow plants. Imagine filling up spaceships with fuel right on the moon before flying off to other planets. Not only does that sound pretty cool, but it's also economical and convenient. That would save us a ton of money and effort. And if we're already stopping to refuel, why not stick around and set up shop? It's about building a whole new space base and turning the moon into a launching pad for exploring deeper space. A moon base would let scientists study wild space weather, practice building habitats, and test robots in real lunar dust. I can't be the only one excited for the future where robots stream their live missions from the moon. The skills and knowledge we develop there could be essential for living on Mars or exploring the moons of Jupiter and beyond. This is not as far-fetched as you might believe. Companies like Astroforge and Karman Plus are working on tech to mine asteroids, and maybe the moon someday. NASA's Artemis program is trying hard to set up a sustainable human presence on the moon in the next decade. And Europe's space agency is also eyeing lunar resources. So yeah, the idea of people and robots working together on the moon is probably just a matter of time. Still, it's not as simple as it sounds. There are big questions that humanity faces. Just like with the original gold rush, it's a bit of the Wild West when it comes to rules. The Outer Space Treaty, signed in 1967, says no country can claim the moon as its territory. However, it's pretty vague when it comes to private companies mining resources. So, if you build your rocket and mine some platinum first, is it yours? Well, as for right now, it's a guessing game. Countries are debating and trying to figure it out before the space gold rush turns into a lunar free-for-all battle royale. Then, there's the challenge of protecting the moon's one-of-a-kind environment. Some craters are so quiet that scientists dream of turning them into giant space observatories that study the universe without any radio noise from Earth. Mining nearby could shake things up or kick dust into the air. Lunar soil could damage the sensitive gadgets and ruin the billion-dollar science experiments. That would definitely annoy researchers. Plus, some parts of the moon have been untouched, and mining could wipe out cool spots we haven't even fully explored yet. So basically, we want to make sure we don't turn the moon into a lunar construction site before we've learned all its secrets. That's why some experts suggest setting up protected zones on the moon, like national parks here on Earth, where mining and heavy machines just aren't allowed. That way, we get the benefits of lunar resources but keep the moon's most important areas safe for research and discovery. But here's an even bigger question. How is this thing going to affect us casual Earthlings who can't take a walk up to the moon with our metal detectors and explore? The moon's rare metals aren't just worth a lot. They could actually be super useful for future tech. Platinum group metals, which might be found in lunar soil, are used in things like medical gear, satellites, and even some types of batteries and fuel cells. If the moon really is sitting on $1 trillion treasure, it could boost tech industries and possibly lower costs. There's also helium-3, a rare isotope found on the lunar surface. Scientists think it could someday be used for nuclear fusion, providing a clean, powerful source of energy that doesn't create greenhouse gases or long-term radioactive waste. If fusion becomes possible, even small amounts of helium-3 could power entire cities. One cool perk of using resources from space is that we could cut down on all the digging and pollution here on Earth. That means less damage to our environment and more sustainable ways to keep up with our growing population's needs. On the other hand, all these new opportunities could create new challenges. Of course, there's going to be a cosmic tug-of-war with who gets the goodies. Nobody wants the fear of missing out on a moon rush. Bottom line, lunar mining isn't just a science experiment. It's something that could affect economies, technology, and the environment here on Earth, for better or worse. When I was a kid, hundreds of years ago, we had the moon bases on the covers of our science books. One of the reasons why moon landing projects became so rare is that it just wasn't financially viable. Why should a country spend resources to get to the moon if there's nothing valuable up there? However, now that we think there's something out there, everything could change. That's why I already imagine myself working 9 to 5 on the moon, fixing robots and growing moon plants. But it's time to get back to Earth, so to speak. Nobody's setting up a moon McDonald's or booking lunar Airbnbs just yet. Even the most optimistic experts say we're still decades away from big mining operations or permanent lunar bases. For now, most missions will be robotic, experimental, and with price tags that will make your head hurt. So until we all get our moon mining helmets, it's something to think about while moon gazing. What about that wealth hiding on the bright side of the moon? Thank you for watching.
The moon's surface has millions of craters, but something else has drawn a lot of attention to it. A giant rare hole that turned out to be a tube. It was found when the Japanese lunar orbiter was gathering data around the moon's skylight, the tube's entrance. Researchers found a specific echo pattern that suggested there was a hollow area. They discovered more echo patterns at a couple of places near the hole, so there could be more lunar tubes there. But in this big tube, you could place an entire football field and the pit could swallow it whole. It's irregularly shaped and 427 feet in diameter. Scientists think that there could be secret caves, a tunnel system, or an entire geological wonderland under the surface. It could be a good shelter for astronauts that land on the moon, or even be a harbor for a lunar colony. No one ever managed to stay on the moon for more than 3 days because of the conditions on the satellite. It has a wide range of temperatures, low atmosphere, and no magnetic field that would protect life on the surface from things like radiation or harsh sun rays. Astronauts wear spacesuits, but they can't protect them over long periods of time. But a lava tube could. When a lava flow cools, it gets a hard crust, which later thickens and creates a roof over that same lava. It continues to flow, but when it stops, the channel can drain, which results in an empty tube. Our planet also has lava tubes, but they're not as big as the one found on the moon. There's a special type of tree called a moon tree. It's grown from seeds that were taken into space during one of the missions and then returned back to Earth. You can find this kind of tree growing across the US. Earth is 27% bigger than the Moon and far more massive. Our gravity is stronger. If you drop a rock on the Earth, it will fall faster. 150 pounds on Earth is just 25 pounds on the Moon. The Earth has numerous satellites circling around it, but the Moon is the only natural one. Our Moon was formed during a big collision of the Earth and one more planet the size of Mars. This happened around 4.6 billion years ago, shortly after the Sun and our solar system were formed. After the collision, a cloud of vaporized rock went into orbit around our planet, cooled, and shaped into a ring of small solid bodies. They later got together and became the Moon, leaving craters as a reminder of this collision. If you're standing on the surface of the Moon, your shadow will be darker than on Earth. This is because there's no atmosphere to scatter light and create lighter shadows. One of Jupiter's moons, Io, has hundreds of volcanoes and pretty wild eruptions, sometimes sending plumes 250 miles into the atmosphere. These eruptions happen because of the extremely strong gravity this moon is exposed to. Its insides tense up and relax in those periods when it gets closer to and then further from Jupiter, which generates enough energy for insane volcanic activity. It's not just planets, even quite small space bodies sometimes have moons. In 1993, researchers discovered a 20-mile wide asteroid and its 1-mile wide moon. You'd need 400,000 moons to match the brightness of our central star, the Sun. The moon reflects the light it gets from the Sun, but it doesn't produce its own. That brightness depends on the angle between the moon, the Earth, and the Sun. Our moon is around 32 Earths away from us, and 29 Earths at its closest. When the night is dark and clear, it seems like you can touch a full moon. But if you wanted to do it, you'd have to travel up to 250,000 miles. Still, there is water on the moon. Not puddles or lakes, but grains of water ice exist in permanently shadowed parts near the moon's poles. Scientists think that water got on the moon a long time ago, during a period when both the moon and Earth were constantly struck by asteroids and comets, which contained water ice. This process may have even helped us get our own lakes and oceans, not just the moon's icy water. Newer research says that the moon's interior already had water, and it went to the surface during volcanic activity. The same might have happened on our planet too. Out of 200 moons in our solar system, our moon is the 5th biggest one. Jupiter's moon Ganymede is the biggest one, almost 1.5 times bigger than ours. Apollo 11 was the mission where humankind first landed on the moon. It was a very important moment, broadcast all over the world. But it was almost interrupted by a huge windstorm that was going on in Australia back then. Parker Dish was placed there, which was something we used to get the broadcast signals from the moon. The moon is not a perfect circle. It's more in the shape of an egg, with the thicker end pointing toward us. This shape is derived from its rotation. A full moon can keep you awake. Studies showed that people experienced less deep sleep, and it took them longer to fall asleep during the full moon period. It wasn't about its brightness, but the lunar cycle that influences our internal body clock. Each year, the moon is moving away from Earth because of the interaction between the moon's gravitational force and our oceans. In 1 year, it moves around 1.5 inches away, which means that in around 600 million years, it will be 14,600 miles further from Earth than it is now. This number isn't accidental. That's the time when total solar eclipses will stop happening. Humankind hasn't set foot on the moon in a few decades, but footprints there are still fresh because there are no winds up there, so these tracks can stay there for millions of years. The moon has its own time zone called lunar standard time. Time is different on the moon, so a year there is divided into 12 days, considering each is as long as our month. Days got named after astronauts who walked on the moon. The moon calendar starts the moment Neil Armstrong stepped onto the moon in 1969. There are possible energy sources for living beings on one of Saturn's moons. It has an ocean under the surface, and it may feature some chemical reactions similar to those that help certain forms of life on our planet survive. The moon used to have active volcanoes, probably during the time of the dinosaurs. Molten lava hardened on its surface billions of years ago, which helped create unique lunar craters, but the volcanoes have been dormant for a long time now. The moon has earthquakes, or rather, moonquakes. Just like our planet, the moon also has a crust that goes through changes and shifts. Shaking occurs when its crust warms and expands, or it can even be caused by meteorite impacts. Moonquakes are not as strong as earthquakes, but can last way longer since the moon doesn't have enough water to prevent seismic vibrations. The moon has a big range of temperatures because it doesn't have an atmosphere. During the day, it can go up to 200 degrees Fahrenheit, but at its poles, the temperature is around -400 degrees Fahrenheit. In 2019, astronauts discovered a strange space phenomenon. The moon was crossing in front of the sun, and at one moment, it seemed like it stopped and then started moving backward. It's the same optical illusion like when you're driving on the highway and pass a car that's slower than you. At one moment, as you move ahead, it may appear like it's going backward. The crust of the moon is not equally thick in all its parts. Some are up to 37 miles thick, while others are much thinner. The moon itself doesn't change colors. When sunlight goes through our atmosphere, it reflects off the moon and makes us see it as pink or red. Sometimes there are particles of dust sent into the atmosphere, and in combination with sunlight, they give the moon an orange glow. The moon doesn't have a dark side. There's only a far side that we can't see from the Earth. The moon spins on its axis once and makes a circle around the Earth, all in the same amount of time, which is why we only see its one face the entire time. All planets in our solar system have at least one moon, except for Mercury and Venus. Mercury has less mass than our planet, so its gravity is lower than ours, around 38% of the Earth's gravity. That means 100 pounds on Earth would be 38 pounds on Mercury. Because of the weaker gravity, and since it's so close to the Sun, Mercury wouldn't be able to have its own moon. It would probably crash into Mercury, or even go into orbit around the Sun, and someday even get pulled into it. Venus most likely doesn't have its moon because it's also too close to the Sun. The space crew had been getting ready for the launch for over 3 years. The preparations for landing on the strange planet included gathering and studying rock samples in the Grand Canyon, exploring ancient volcano formations in the Nevada National Security Site, and looking into gas and lava vents, lava lakes, and pit craters in various locations in Hawaii. To be able to resist microgravity conditions, they learned how to walk obliquely by being strapped and suspended sideways and trying to move along walls. They had to test their limits through intensive diet and sleep regimens to make sure they'd be safe in outer space. It took them 3 days, 3 hours, and 49 minutes to reach the surface of this new world in a place called the Sea of Tranquility. They could have gone for the Ocean of Storms or the Central Bay, but they chose this place to land because it had good visibility and it was relatively smooth and easily reachable with as little propellant as possible. One of the first things they noticed when they got there was that, well, the place kind of smelled. This may sound like the beginning of a science fiction novel, but it's actually the true story about how the Apollo 11 mission landed on the moon on July 20th, 1969. Since then, the moon has had 12 human visitors to this day. We think of it as our neighboring space buddy, but there's still much we don't know about this mysterious satellite. And that should come as no surprise, since the moon is actually always showing us the same face. That is because the Earth and its only permanent natural satellite are in synchronous rotation, which makes us think it's always permanently still. The truth is, it's not in a fixed position, and it is actually moving further and further away from the Earth each year by 1.5 inches. Believe it or not, the Earth and the Moon, although being 238,855 miles apart, deeply influence each other. While the Moon is partially responsible for the tides of the seas and oceans on our planet's surface, our Earth is actually to blame for movement on the Moon. They're called moonquakes, and they last way longer than earthquakes, some of them up to half an hour. It may look perfectly round to us on a warm summer's night, but the Moon is actually oval. The lemon-like shape is caused by the Earth's gravitational pull. Our moon features more than footprints when it comes to traces of humans. In 1969, American astronauts left many objects on the surface of our satellite, such as 2 golf balls, a drawing by famous artist Andy Warhol, and a message from Queen Elizabeth II herself. One of the last people to walk on the moon to this day, an astronaut named Eugene Cernan, scribbled his daughter's initials on the moon's surface in 1972. Since it appears there's no wind or any other type of weather change there, the letters TDC could remain there permanently. It's actually possible to be allergic to the moon. Harrison Jack Schmitt, an astronaut from the Apollo 17 mission, spent some time in a valley in the Sea of Serenity, then climbed back into the crew's lunar module, but had some moon dust on him. Just as he removed his spacesuit, he got red eyes, sneezing fits, and other allergic reactions that lasted 2 hours. Since it's so close to us, we've established that the moon has a time zone of its own. We call it the Lunar Standard Time, but it doesn't correspond to time on Earth. To get an equivalent, the explanation is a bit more complex, but in simple terms, a year on the moon is split up into 12 days, each one about as long as a month on Earth. Each one of these days got its name after a different astronaut who has walked on the moon. The start date of this calendar coincides with the moment Neil Armstrong walked on the moon. So, the Lunar Year 1, Day 1, began on July 21st, 1969 at 2:56:15 Universal Time. Since the moon has a very thin atmosphere, it has some pretty crazy temperatures, both hot and cold. They can go up to 200 degrees Fahrenheit. Over by the moon's poles, however, the temperature is always at around minus 400 degrees Fahrenheit. Humans have tried to trace the connection between our natural satellite and the Earth for as long as we can remember, coming up with words to explain why the moon's existence influences us so. In the Middle Ages, scientists and philosophers thought that during a full moon, some people were more likely to experience different health conditions. Because they saw this inexplicable connection to the full moon, people with these symptoms were named lunatics, or at times, literally, moonsick. People are not the only creatures living on Earth that are affected by moon cycles. Dog owners are 28% more likely to take their pet to vet emergency rooms during the full moon. You may think that's the reason why wolves have this preference for howling at a full moon, more so in popular culture. But scientists haven't been able to find any connection between wolf behavior and the lunar cycles, so it might as well just be a myth. The largest known crater in our solar system is also found on our moon, and is called the South Pole Aitken. This giant formation is located on the far side of the moon and measures 1,550 miles in diameter. One of the many things we've yet to fully understand about our satellite is the unusual flashes of light that can sometimes be seen on its surface. Scientists have named these outbursts transient lunar phenomena, or TLP in short, and they have been seen all over the world for centuries. One of the first instances of TLP dates back to 1178, when monks from Canterbury claimed to have seen a flaming torch on the surface of the moon after the sun had set. TLP does not simply mean light flashes. Reports also have detailed other unusual events, such as gas-like mists, reddish, green, blue, or violet colorations, or even the darkening of certain locations on the moon. Is something strange happening with our moon? Is it the beginning, or did we just start noticing it with the newer space study equipment we have nowadays? There are a lot of different theories that scientists have developed trying to piece together what can be causing these events. The unusual flashes on the moon can be caused by anything from meteoric impacts to electrostatic activity. It's difficult to pinpoint the explanation for each event, since most of these episodes are recalled either by a single observer on Earth or from a single location. The fact that there is noticeable seismic activity on the moon can also explain why we can sometimes see unusual flashes of light on the surface of our satellite. When the moon's surface moves, it can cause different light-reflecting gases to erupt, which can explain luminous developments. Some scientists have even suggested that residual geologic activity may also be the cause. This is all the more shocking, given that we've always looked at the moon as a lifeless world. Did you ever notice that our moon can change its color? There are actually many scientific explanations for that. The moon appears to be a brown-tinted gray when you look upon it from outside of the Earth's atmosphere. When gazed upon from the Earth's surface, the moon appears to change color depending on various phenomena. The moon seen near the horizon will most likely be yellow or red-tinted. The rarer blue-colored moon indicates that you're looking at our satellite through an atmosphere carrying larger dust particles. The moon can even appear purple at times, But what causes this specific hue is still up for debate. The fact that we don't know exactly if or how much water there is on the moon's surface is not the main reason why we aren't already building houses up there. It seems that radiation actually has a lot more to do with it. Recent studies have shown that the moon's surface has a radiation rate 5 to 10 times higher than that you experience on a transatlantic passenger flight. That also means it's 200 times higher than the rate on the Earth's surface. In future lunar explorations, like the Artemis project for example, scientists need to take this into consideration, not to expose the astronauts. Named after Artemis, Apollo's sister, this program aims not only to place astronauts on the lunar surface in the future, but also to build some sort of an establishment there to study the moon in safe conditions. While the project started in 2017, the first planned mission is set for launch in summer 2022, with an estimated duration of 25 days. The space object, with no crew on board, is planned to reach lunar orbit and safely return with sufficient data for the next 4-person mission scheduled for May 2024. Artemis 3, 4, and 5 are expected to be launched in 2025, 2026, and 2027 respectively, each with a planned duration of approximately 30 days.
Hey, does anyone remember the gold rush? Back in the 19th century, prospectors were flooding California rivers with a pan in hand, chasing wealth. Well, scientists now say it might be time for the moon rush, because apparently precious metals worth over $1 trillion could be hiding underneath the surface of the moon. That's a lot of money. However, can we really reach it? And if so, who does it belong to? If you have ever paid close attention to the pictures of the moon, you probably noticed a lot of holes and craters. Our satellite is like a giant Swiss cheese. It has over 1.3 million craters, if you count those larger than 0.6 miles. But today, we're focusing on about 6,500 really big ones, those over 12 miles wide. Those were not made by little green men or little green moles, but rather by asteroids crashing into the moon since eternity. Scientists compared moon scans to meteorites, and after crunching the numbers, they think there could be a fortune in platinum hiding in those craters. What's exciting is that many of these resources could be just a few feet beneath the surface. The moon doesn't have an atmosphere like Earth, so there's no wind, rain, or earthquakes messing things up. That means those asteroid crashes left their priceless metals pretty much right where they landed, undisturbed in lunar dust for millions of years. With each crater like a giant space bowl catching platinum, iridium, palladium, and other metals. On Earth, we have to drill super deep just to get a tiny bit of these. By the way, did you know that most of the mineable gold on Earth likely came from ancient meteorites? When Earth first formed, almost all the original gold sank into the core. The stuff we can actually dig up today is probably what's left when space rocks slammed into the crust billions of years ago. So maybe you wonder why not reach for the asteroids and mine there? Well, that's because they're out of reach. Yes, in theory, it would be possible to mine from asteroids, but obviously the moon is way closer and easier to get to than any other giant rocks floating in space. We've already walked on it and brought back pieces of it to Earth, so it's fair to say we are familiar with it. This makes mining it a much smarter step than chasing unpredictable asteroids. However, asteroids are next on the list. Also, when it comes to mining the moon, it's not just about the prize. Some of those craters have frozen water. We know that because several missions, like NASA's Lunar Reconnaissance Orbiter and India's Chandrayaan-1, have found frozen water ice in dark craters near the moon's poles. This ice is super valuable because it can be broken down into oxygen and hydrogen. They are the parts needed to make rocket fuel. It could also be purified for astronauts to drink, or even used to help grow plants. Imagine filling up spaceships with fuel right on the moon before flying off to other planets. Not only does that sound pretty cool, but it's also economical and convenient. That would save us a ton of money and effort. And if we're already stopping to refuel, why not stick around and set up shop? It's about building a whole new space base and turning the moon into a launching pad for exploring deeper space. A moon base would let scientists study wild space weather, practice building habitats, and test robots in real lunar dust. I can't be the only one excited for the future where robots stream their live missions from the moon. The skills and knowledge we develop there could be essential for living on Mars or exploring the moons of Jupiter and beyond. This is not as far-fetched as you might believe. Companies like Astroforge and Karman Plus are working on tech to mine asteroids, and maybe the moon someday. NASA's Artemis program is trying hard to set up a sustainable human presence on the moon in the next decade. And Europe's space agency is also eyeing lunar resources. So yeah, the idea of people and robots working together on the moon is probably just a matter of time. Still, it's not as simple as it sounds. There are big questions that humanity faces. Just like with the original gold rush, it's a bit of the Wild West when it comes to rules. The Outer Space Treaty, signed in 1967, says no country can claim the moon as its territory. However, it's pretty vague when it comes to private companies mining resources. So, if you build your rocket and mine some platinum first, is it yours? Well, as for right now, it's a guessing game. Countries are debating and trying to figure it out before the space gold rush turns into a lunar free-for-all battle royale. Then, there's the challenge of protecting the moon's one-of-a-kind environment. Some craters are so quiet that scientists dream of turning them into giant space observatories that study the universe without any radio noise from Earth. Mining nearby could shake things up or kick dust into the air. Lunar soil could damage the sensitive gadgets and ruin the billion-dollar science experiments. That would definitely annoy researchers. Plus, some parts of the moon have been untouched, and mining could wipe out cool spots we haven't even fully explored yet. So basically, we want to make sure we don't turn the moon into a lunar construction site before we've learned all its secrets. That's why some experts suggest setting up protected zones on the moon, like national parks here on Earth, where mining and heavy machines just aren't allowed. That way, we get the benefits of lunar resources but keep the moon's most important areas safe for research and discovery. But here's an even bigger question. How is this thing going to affect us casual Earthlings who can't take a walk up to the moon with our metal detectors and explore? The moon's rare metals aren't just worth a lot. They could actually be super useful for future tech. Platinum group metals, which might be found in lunar soil, are used in things like medical gear, satellites, and even some types of batteries and fuel cells. If the moon really is sitting on $1 trillion treasure, it could boost tech industries and possibly lower costs. There's also helium-3, a rare isotope found on the lunar surface. Scientists think it could someday be used for nuclear fusion, providing a clean, powerful source of energy that doesn't create greenhouse gases or long-term radioactive waste. If fusion becomes possible, even small amounts of helium-3 could power entire cities. One cool perk of using resources from space is that we could cut down on all the digging and pollution here on Earth. That means less damage to our environment and more sustainable ways to keep up with our growing population's needs. On the other hand, all these new opportunities could create new challenges. Of course, there's going to be a cosmic tug-of-war with who gets the goodies. Nobody wants the fear of missing out on a moon rush. Bottom line, lunar mining isn't just a science experiment. It's something that could affect economies, technology, and the environment here on Earth, for better or worse. When I was a kid, hundreds of years ago, we had the moon bases on the covers of our science books. One of the reasons why moon landing projects became so rare is that it just wasn't financially viable. Why should a country spend resources to get to the moon if there's nothing valuable up there? However, now that we think there's something out there, everything could change. That's why I already imagine myself working 9 to 5 on the moon, fixing robots and growing moon plants. But it's time to get back to Earth, so to speak. Nobody's setting up a moon McDonald's or booking lunar Airbnbs just yet. Even the most optimistic experts say we're still decades away from big mining operations or permanent lunar bases. For now, most missions will be robotic, experimental, and with price tags that will make your head hurt. So until we all get our moon mining helmets, it's something to think about while moon gazing. What about that wealth hiding on the bright side of the moon? Thank you for watching.
So this thing, Cosmos 482, a high-tech capsule, was built to survive even the most extreme heat of another planet. But something went wrong. It never made it out of Earth's orbit. For over 50 years, it drifted silently around the planet. Forgotten until now. In May 2025, gravity finally pulled it down. It's coming home, built to survive re-entry and unpredictable enough to crash anywhere. No warning, no parachute. Just a 1,000-pound sphere falling from the sky, a human-made meteorite capable of causing chaos. In 1972, this funny-looking ball was sent on a Venus-bound mission. Now, Venus is like Earth's evil twin. It's similar in size, but that's where the similarity ends. It's the hottest planet in the solar system, where temperatures reach 860 degrees Fahrenheit, hot enough to melt lead. Atmospheric pressure is about 93 times greater than Earth's, which is like being 3,000 feet underwater and you feel like you're in a trash compactor. And the atmosphere itself is made of carbon dioxide, with clouds that literally rain sulfuric acid. So yeah, it's pretty bad. Yet Cosmos 482 was fully expected to reach it and land. Not for long though. A type of self-destruct scouting mission. The spacecraft was designed to land and transmit data, hopefully for at least a few minutes. On the surface that crushes, bakes, and basically dissolves anything that touches it. How? Well, it came with heat shields for the fiery plunge, a mini AC to cool just long enough, and armor tough enough to handle Venus's brutal environment. It was truly a high-tech reinforced vault built for a one-way trip. And this was in the early 70s, mind you. Fun fact, even today, we've never built anything that could survive that kind of environment. We have deep-sea submersibles that can handle big-time pressure, but not the heat. There are space capsules that can withstand extreme temperatures, but only for a few minutes. Even nuclear reactor walls, designed to handle serious pressure, would crumble if acid rained on them nonstop. Now, a funny twist of this story is that landing on Venus was already achieved in 1970. Venera 7 became the first spacecraft to land on another planet and transmit data back to Earth, surviving on Venus's surface for a full 23 minutes before melting down. It proved the impossible was possible, just not for Cosmos 482. So, what went wrong with Cosmos 482? We've always imagined space travel as firing up the spaceship, launching it, and that's it. However, that's not how it works. First, with an initial boost, you park it in Earth's orbit, like pulling into space's driveway. Then comes a second burn, a precisely timed engine firing that pushes the spacecraft out of orbit and toward its destination. Cosmos 482 made it to the parking orbit just fine, but something went wrong with the second push. No push means no trip, so instead of heading to Venus, it got stuck circling Earth for the next 50 years. But why does something get stuck orbiting for so long? Well, when something gets launched into space, it's not just going up. It's also going really fast sideways. If you throw a baseball up hard enough, it'll eventually hit the ground. But if you could throw it fast enough and Earth wasn't in the way, it would just keep falling around the planet. That's what orbiting means, falling but never hitting the ground. The object's forward speed balances perfectly with the gravity pulling it down. So, to leave Earth, a spacecraft needs to pass through 3 layers. The first is low Earth orbit, or LEO, a few hundred miles up. Here is where satellites, the space station, and tons of leftover junk circle the planet. Cosmos never made it past this point. If the second launch had been successful, it would have gone through medium Earth orbit, where GPS satellites cruise. Then, way out at 22,000 miles, there's geostationary orbit, the sweet spot for weather reports and TV. So now we know how Cosmos ended up there and why it was orbiting for so long in LEO. But what made it suddenly change its mind and fall back? Even in Leo, space isn't completely empty. There's still a tiny bit of atmosphere up there, and over time, it acts like a brake, slowing things down just enough. Think back to that baseball you threw sideways fast enough to orbit Earth. Eventually, it will slow down to the point where gravity takes over. However, Earth is securely protected by its atmosphere. As objects fall back to Earth, their speed keeps increasing up to tens of thousands of miles per hour. When you're moving that fast, the air pushes back really hard. That push creates friction, and friction creates heat, a lot of it. The surface of falling objects can reach over 3,000 degrees Fahrenheit, causing them to melt, shatter, or vaporize completely before they ever hit the ground. That's why scientists don't lose sleep over small debris. Small pieces of old satellites, even tools lost during spacewalks, fall all the time. But they burn up like shooting stars. We just never notice them. Now, a baseball would disintegrate instantly. But what about a giant ball designed to withstand landing on Venus? Thankfully, this potentially horrifying story is anticlimactic, because Cosmos crashed into the Indian Ocean west of Jakarta on May 10, 2025. Radar picked it up streaking through the sky, glowing, breaking, heating up, but still intact enough to make it all the way down. And it did, thankfully, not somewhere crowded. However, now that it's lost beneath the waves, we are free to speculate. How real was the danger? Could it have fallen into a crowded area? Absolutely. If that 1,000-pound capsule had come down over a city, it could have smashed through rooftops, wrecked cars, or worse, seriously injured someone. And no, there wouldn't have been sirens or alerts. Cosmos 482 was launched in the 1970s, long before GPS or live tracking, so there was no signal to follow, no proper guidance system. Scientists could only make rough estimates about where it might land, so if it had come down over land, it would have looked like a meteor. Well, the story of Cosmos, with the K, had a happy ending. But it's not the only thing up there that could fall down. As of early 2025, about 11,700 satellites are active. But with roughly 14,900 in orbit, that means over 3,000 are no longer operational. And the space junk keeps piling up. Space tracking systems monitor more than 40,000 objects that are bigger than a softball, such as pieces of old satellites and bits of rockets. Scientists estimate there are over 1 million fragments larger than a half an inch, and more than 100 million smaller bits still floating around. These can't hurt us down on Earth, but most of it clutters Leo, where collisions can generate explosive clouds of debris, damaging satellites and space stations. Just one crash can trigger a chain reaction called Kessler syndrome, where each impact creates more debris, leading to more collisions until Earth's orbit turns into a demolition derby. Remember the movie Gravity? Yeah, like that. And yes, bigger things from Leo do fall. Cosmos 482 wasn't the first space object to come crashing back. In 2016, Tiangong-1 space station lost contact and tumbled back to Earth 2 years later, eventually burning up over the Pacific. In 2001, the famous Mir station was intentionally brought down. And before that, in 1991, Salyut 7, another space station, unexpectedly deorbited. The 40-ton station broke up on re-entry, and parts that survived scattered over Argentina. Among others, in 1979, NASA's Skylab, the very first American space station, fell back to Earth with only partial control. Pieces of it rained down across Western Australia. Some newspapers even offered cash rewards to anyone who found a chunk. So, we've seen this happen before. Cosmos was just the latest reminder. But NASA and other space agencies do think about this problem. And most modern spacecraft designed to return have parachutes, heat shields, and built-in safety systems to guide them home, but not working satellites and old junk. Yeah, they're still up there. So next time, a space object might not land safely in the ocean. It might crash through your roof while you're watching a Brightside video. But don't worry. So, you wake up after a nap. You flick the light switch. Nothing. It's still pitch black. Your phone battery's gone. The charger's useless. No Wi-Fi, no TV, just static on the radio. You are completely cut off. You move to the window and see that the entire city is in darkness. Then, out of nowhere, the night sky explodes into swirling shades of green, purple, and blue. It's an aurora borealis in a place where it should never happen. So, what's going on? What sounds like a real modern-day nightmare might come true if a super powerful solar storm hits Earth, and it could cost trillions of dollars in the United States alone. So now scientists are building some kind of warning system. It's a space traffic light, helping to protect us from the hidden dangers of our own life-giving sun. Now, first things first, solar storms are giant bursts of energy that come from the sun. Imagine the sun as this big sphere, wrapped up in a chaotic mess of magnetic fields, just like your fine strands of hair after a rough night's sleep. Now, as the sun spins, those magnetic fields start to twist up. But here's the thing, they don't all move at the same speed, and that's what throws everything off balance. Because those tangled magnetic fields get stretched and twisted so much that they eventually snap and reconnect. And when that happens, boom, tons of energy gets released and races through space. A solar storm is exactly that, a sudden outburst of energy, particles, magnetic fields, and hot material thrown out by the sun. And it usually shows up in three powerful forms. First up, the solar flare. This is a bright flash of radiation or light that puts on a spectacular show. These are the most powerful explosions in our solar system. Solar flares send out all kinds of energy across the electromagnetic spectrum, including X-rays, gamma rays, and radio waves. Next, the radiation storm. This happens when the sun launches charged particles, like electrons and protons, into space at super high speeds. Just to give you an idea, the quickest particles can cover the 93 million miles from the sun to the Earth in just 30 minutes. And finally, the coronal mass ejection. This is when massive clouds of plasma explode from the sun's outer layer, known as the corona. From afar, it looks like giant bubbles popping off the sun's surface. These blasts are so strong, they can shoot billions of tons of material deep into the solar system in one powerful burst. Okay, so solar storms are blasting all this stuff out into the solar system. And that should be fine, except it's not, because it can affect us. When a solar storm is headed toward Earth, things can get tricky. If it slams into our magnetic field, it triggers what's known as a geomagnetic storm, and that can seriously mess with our daily lives. Take satellites, for example. A strong geomagnetic storm can damage them or make them shut down for a while. GPS systems, like the one in your phone or car, can stop giving accurate directions. Signals from TV might glitch or cut out. Even phone calls could drop or sound weird. On a larger scale, the internet itself could run into serious trouble. If service providers go down, all the systems that rely on the web to stay connected might stop talking to each other. That could leave countless people and businesses completely offline. Experts say this kind of internet apocalypse scenario could cost anywhere from $600 billion to a staggering $2.6 trillion in damages. And that's just in the United States alone. Radio communication might also take a hit. And that's a big deal, because during a major blackout, it's usually one of the few ways we can still get news. But the trouble doesn't stop there. It can also mess with flights all around the world. And for everyday people, that could mean grounded planes, delayed trips, and total confusion at airports. It can also send extra electrical current flowing through power lines. That sudden surge can overload transformers and knock out the power. This isn't just a what-if situation. It really happened in Canada back in 1989, for example. A solar storm left the entire province of Quebec plunged into darkness for 9 hours straight. Although powerful solar storms don't hit Earth often, they can and do happen. In fact, one struck in May of 2024. You might remember the news. Social media was flooded with photos and videos of strange auroras lighting up the sky in shades of green, red, and blue. But the wild part is that these auroras showed up in places where they're not supposed to. People in countries like Brazil, South Africa, Turkey, South Korea, Spain, and many others got to see this stunning sky show for the very first time in their lives. And all of that happened because of a solar storm, the Gannon storm. Yep, when a solar storm is strong enough, it pushes the auroras far beyond their usual zones, making them visible in places much closer to the equator. Now, although they're still considered rare, powerful geomagnetic storms are happening more and more often. That's because the sun is experiencing what's called the solar maximum. Basically, it's a peak in solar activity that happens about every 11 years. So, when's the next big solar storm going to hit us? Well, maybe soon. NASA says an event like that could happen sometime in 2025. It might strike next week or maybe a few months from now. But here's the tricky part. No one knows exactly when it will happen. It's tough to predict it because the sun is complex and always changing. So there is a lot of uncertainty around the speed and direction of solar storms. That's why we've got satellites floating about 1 million miles from Earth just to keep an eye on them. But here's the problem. When a big solar explosion happens, it can reach Earth in just one day. And since our satellites are still pretty close to us, we only find out the important stuff, like the direction of the magnetic blast, perhaps only an hour before it hits. And that's barely any time to act. It makes it super hard to prepare and protect things we rely on every day, like power lines, internet service, phone networks, and satellites flying above us. So today, we're just hoping for the best. And that brings us back to why we need a traffic light system to protect us from solar storms. The main goal of the Pager project is not to predict when the storm might hit, but also to understand how bad it could be and what kind of damage it could cause here on Earth. This traffic light will be an algorithm. It will collect information from telescopes watching the Sun and from satellites orbiting Earth. Then it will feed that data into advanced models. These models can predict how much radiation is in space, how it might affect spacecraft, and what kind of impact it could have down here on the ground. This will also help satellite operators decide if space conditions are safe or not. Just like your local weather forecast tells you if you might need an umbrella. This system will do the same for satellites, warning them when it's better to power down or stay protected. But the main idea is that this tech could give us a heads up way earlier about dangers coming from the sun. With these traffic light calculations, we might know when a solar storm is coming and how strong it will be up to 2 days in advance. That's a big deal, because this will finally give us a chance to be better prepared for the next one.
There are tons of weird things on Mars. Spoons, noodles, doors, even faces. Are they all really just rocks? Besides, it's not the only planet in our solar system full of mysterious things. Let's check them out. Recently, we found a strange thing on Mars that looks like a smooth, spoon-like object. It grabbed everyone's attention after NASA's Curiosity rover spotted it. The rock, with a handle and rounded tip, looks like it's floating in the rover's photo. People on the internet are puzzled about what it might be. Some are joking that it's a Martian's bowling pin, or even a shoehorn left by extraterrestrial creatures. But Andrew Good from NASA says it's not that exciting. Turns out it's just a rock shaped by the wind over a long time. These kinds of rocks with odd shapes are common on Mars. They're called ventifacts. Ventifact is a rock that can get scratched, dented, or smoothed out by tiny particles carried by the wind. You'll usually find these kinds of rocks in dry places where there's not much grass or trees to block the wind, and where there's a lot of sand blowing around. Sometimes, the wind can carve ventifacts into really cool shapes, like the mushroom rocks you can see in the White Desert National Park in Egypt. These rocks look like giant mushrooms because the wind wears away the bottom part faster than the top, making them stand tall and slim. Ventifacts aren't the only cool Martian rocks. Check out this series of surreal spikes protruding from the red surface. NASA's Curiosity rover stumbled upon them while exploring the Gale crater on Mars. They quickly caught everyone's attention. Twisting structures resembling spikes looked like some extraterrestrial doors. Even the SETI Institute, an organization focused on searching for extraterrestrial life, tweeted about the image, referring to it as a cool rock. But in reality, these are just hoodoos. These tall and thin spires occur when hard rock sits atop softer rock layers. Martian spikes are likely cemented fillings of ancient fractures in sedimentary rock, with softer material eroded away over time. Again, there are many hoodoos on Earth too. They're also called fairy chimneys or tent rocks. You can find them in places like Utah's Bryce Canyon and the Colorado Plateau. NASA is excited about these weird structures because they can help us learn more about the history of the Gale crater. There was also a rock that looked like a jelly donut. We called this rock Pinnacle Island. It was spotted by NASA's cameras. However, just 4 days earlier, it was nowhere to be seen. So how did it magically disappear? In a very anticlimactic way, it was kicked up by one of Opportunity's wheels as it traversed the Martian terrain. But there's still some mystery surrounding that jelly donut. Analysis revealed that Pinnacle Island contains unusually high levels of sulfur and manganese. Both of these things are water-soluble. In other words, there might have been some water action that created these elements in the rock. So this tiny thing suddenly caused a lot of drama, and an entire lawsuit against NASA. It claimed that the agency failed to investigate a possible fungus growing on Mars. Jelly donut fungus. But not all our findings are natural. Another puzzling discovery was this thing the Perseverance rover spotted. It's something that looks like tangled spaghetti or string. Just like the donut, this mysterious object showed up in a rover camera image and then vanished from the sandy ground in several days. It turns out that it could be debris from the rover's landing system. Perseverance landed in the Jezero crater in February 2021. It had a rough landing and accidentally scattered debris around. Some of these debris pieces have been showing up in the rover's images for a while now. The string-like object is likely a piece of shredded Dacron netting, which is a type of fiber used in thermal blankets. These blankets help regulate equipment temperatures during the super hot process of landing on Mars. It probably underwent significant unraveling and shredding due to strong forces during the landing. Thermal blankets lost a bunch of stuff back then. For example, this shiny foil piece spotted in June. The rover found it on a rock. What's remarkable is how far some of the debris has traveled. The rover landed about 1.2 miles away from where it's currently exploring. It's probably because the crash threw the debris into the air, and the Martian winds carried it over such a distance. Mars is known for its strong winds, which can move lightweight objects. However, while it's fun to stumble upon them on images, there are concerns about the debris and trash on Mars. We haven't even fixed this problem on Earth, and we're already creating it on Mars. The debris we left on the red planet is already accumulating in an area called Hogwallow Flats. Plus, the debris can accidentally contaminate the sample tubes used for collecting Martian rocks. So far, NASA isn't overly worried about this, but they're keeping a close eye on it to prevent any issues with the rovers. Now, how about not things, but animals? Curiosity caused quite a stir when it captured something that looked like a rat on Mars. Some started speculating that it could be evidence of indigenous Martian life, or even that this rodent was brought along by Curiosity. But the Mars rat, once again, turned out to be just a weird rock. It looked interesting because of the natural processes like wind erosion and mechanical abrasion. We also found some worm-looking things. Curiosity snapped a picture of a formation that looks like worms wriggling across the Martian landscape. Despite its tiny size, this formation stands out with its unique shape and rough texture. It's probably made of durable material resistant to Mars's harsh erosion. And finally, our top mysterious finding is the face on Mars. Cydonia is a region on Mars that has captured both scientific and popular interest. It's located in Mars's northern hemisphere. It lies between heavily cratered regions to the south and relatively smooth plains to the north. There's a theory that the northern plains may have once been ocean beds. Maybe Cydonia was once a coastal zone. This place is full of interesting and beautiful features that tell us a lot about the history of the Red Planet. But its most interesting feature was the Martian face. This thing gained widespread attention when it was snapped by the Viking 1 orbiter in 1976. Some believed that it was evidence of a long-lost Martian civilization. At first, NASA dismissed it as a trick of light and shadow. But after some analysis, it turned out to be, yep, another rock. We also saw a face of a bear. It was captured by the high-resolution imaging experiment camera. In an image, we can see a circular fracture pattern that looks like a bear's head, with two craters forming the eyes and a V-shaped collapse structure like the nose. The head likely formed because something heavy settled on top of an old hole in the ground. This hole was filled with either lava or mud. The nose-like feature is speculated to be a volcanic or mud vent. But why do we keep seeing these strange things on Mars? Sometimes our brains can trick us into seeing things like faces or objects in rocks and other things. But these are just illusions called pareidolia. Pareidolia is a psychological phenomenon that makes us see familiar patterns or shapes, especially faces, where none actually exist. It's because the brain encounters something it doesn't recognize or understand right away. It tries to find things that look the most like this one. So it sees random patterns, textures, or sounds as something meaningful and recognizable. That's why a chair and clothes on it seems like a super creepy human-like figure at night. It also causes you to see faces or shapes in clouds, or hear recognizable sounds and even words in random noise. It's a fascinating proof of the power of our perception, but we also should be careful with it and not let our imagination run wild. All right, dear viewer, let's lay it out on the table. The case is cold, just like the rock we're looking for. It's that hypothetical planet again, a real slippery character, warping orbits from the shadows. I've been following its gravitational rap sheet for years. It has left a trail of math miscalculations and confused astronomers. But it can't hide forever. This solar system ain't that big. If it's there, we will find Planet Y. Yep, another day, another quest to solve the solar system's riddles. New research points to another hidden world. I have to say, we shouldn't dismiss these theories until they're disproven. Scientists these days are overloaded with a vast amount of data. Thankfully, they have supercomputers going through mountains of equations bound to give a headache to someone like me. But it's how these theories come to exist. At one point, even Neptune seemed like a far-fetched theory. When Uranus was discovered in 1781 by William Herschel, for decades, it looked like the solar system's final stop. But Uranus didn't quite follow the rules. Something was off. Either the laws were wrong or there was an invisible hand out there. Two math nerds, Adams in England and Leverrier in France, picked up the abacus, and there it was. Neptune appeared exactly where predicted. That's a cool point for math. That triumph inspired the next hunt. In the early 1900s, Percival Lowell became hooked on the Planet X theory. He was sure Uranus and Neptune were still wobbling funny, so he pictured a giant mystery world yanking their strings. His team hunted for years. And in 1930, Clyde Tombaugh found Pluto. Pluto is Planet X? Nope, not so fast. Pluto was too small, it didn't fit. The hype faded, and decades later, Voyager 2 showed that weird orbits made sense all along. Planet X, at least Lowell's version, had never existed. Then came Planet 9. In 2016, researchers noticed that distant Kuiper Belt objects weren't scattered randomly. Their orbits clustered strangely, as if something was tugging them into line. They proposed a super-Earth, 5 to 10 times Earth's mass, orbiting hundreds of AU away. Simulations made it look convincing, but no one has seen it yet. A later discovery, a dwarf planet called 2017 OF201, made things even weirder. Some say it weakens the case for Planet 9. Others say it's more evidence. For now, Planet 9 is still a maybe. However, latest research points to another possible candidate, for now called Planet Y. Unlike the others, it's thought to be smaller, closer in size to Earth or Mercury, and hiding just past the Kuiper Belt. Here's the big clue. Way past Neptune, some icy objects are all tilted, like a bunch of marbles moving to the same side while on a flat surface. That shouldn't happen. Gravity should have straightened them out ages ago. The simplest explanation? A hidden planet, quietly warping the outer solar system like a mischievous babysitter. Astronomers check those Kuiper Belt orbits against the solar system's invariable plane, basically the balance point of all the planets combined. If things were normal, the orbits should line up, but they don't. They're all slanted the same way, like a bunch of pencils dropped on the floor, and somehow every single one points toward the same corner. According to researchers, the odds of that happening by chance are only 2 to 4%. That's similar to flipping a coin 5 times in a row and it landing on the same side each time. Astrophysicists ran their fancy calculations and came up with the simplest explanation. You guessed it, another object with strong gravity. The math shows that a world somewhere between the size of Mercury and Earth, orbiting 100 to 200 AU from the Sun, could maintain that tilt. Not too big, not too small, not too far, just the right size and distance to warp the Kuiper Belt without throwing everything else into chaos. And here's where it gets fun. In theory, Planet Y could coexist with Planet 9. Planet 9 is supposed to pull icy orbits into clusters, kind of like a sheepdog rounding up sheep. Planet Y doesn't cluster anything. It tilts the whole playing field instead, which means if both turn out to be real, we might have 2 hidden planets shaping the edges of our solar system in different ways. So why haven't we seen this mysterious neighbor yet? Simple, it's faint. At 100 to 200 AU, sunlight is thousands of times weaker than here on Earth. A planet that far away could only reflect a tiny trickle of light. To our telescopes, it would look like a barely visible speck drifting across a crowded star field. Kind of like trying to spot a sleeping gray cat in a dark cellar with only faint moonlight coming through the window. It doesn't help that Planet Y would move at a snail's pace across the sky. Snap a photo one year and another a few months later, and it might not even look like it moved. Older sky surveys weren't designed to catch something that faint and slow. They're great for spotting fast-moving asteroids near Earth, but hopeless for a dim tortoise crawling at the edge of the solar system. But the hunt isn't over. Astronomers are putting their hopes on the Vera Rubin Observatory. This massive new telescope will take pictures of the night sky in unprecedented detail. If Planet Y is out there, Rubin could be the one to find it. And if it isn't, well, Rubin will give us the best proof yet that it doesn't exist. Who knows, maybe it spots something entirely different. But what if Planet Y is real? Where did it come from? Perhaps it's a leftover chunk from the solar system's wild early years. Billions of years ago, when Jupiter, Saturn, Uranus, and Neptune were still migrating, massive chunks of rock and ice were flung around like cosmic bumper cars. Some merged to become the planets we know today. Others were kicked out entirely, ejected into interstellar space. Planet Y might be one of the lucky survivors, massive enough to hang on in a stable orbit at the fringes. Another possibility is way cooler. Maybe it's a rogue planet. Planet Y might just be the cosmic equivalent of an adopted kid or a wandering stray that found a home. So what would it mean if Planet Y was real? First, it would mean a lot of textbooks getting another edition. New picture books as well. it would also challenge how we think planets form. A Mercury to Earth mass that far doesn't fit the standard model of planets forming near the Sun and staying put. Either the early solar system was wild enough to fling it outward and still keep it bound, or it didn't start here at all and was captured later, stolen from another star. There's another angle: comets. A planet out there could tug on icy bodies at the edge of the solar system, nudging some inward. Over time, that might even have helped deliver water and building blocks for life to Earth, but that's just speculation at this point. However, the biggest question of all would be, what else is out there? If a planet the size of Earth can still slip under our radar, then smaller worlds, icy dwarfs, and other mysteries could be waiting farther out. The Oort cloud might be home to things we haven't even dreamed of yet. Finding Planet Y wouldn't just add a planet, it would open a new chapter in exploring the solar system. So, here we are at the edge of the map, where the streetlights of our solar system flicker out. It's just another theory on top of a dusty desk. Another clue to chase down a dark universe. Some leads have gone cold and turned out to be ghosts. Others, still out there, waiting to be found. Planet Y? The case is still wide open, but one thing's for sure in our solar system: as long as the orbits keep wobbling and the cosmic rug stays wrinkled, astronomers, they'll keep looking. They'll never stop searching for the last planet hiding in the endless dark. Maybe it's just a matter of time. We will see. There's a huge hole on Mars, more than 300 feet wide, and it seems that NASA agrees that it could be an opening into an underground world. Could a mysterious space civilization be hiding in there? Well, experts from NASA think that the hole might lead to a lower layer under the surface of the red planet. You can think of it like a trap door that opens into a basement. Scientists care a lot about holes like this because they might connect to big underground caves. These caves would be hidden from the surface and could be safer places for life to exist. You see, Mars's surface is a rough place. It's freezing cold, extremely dry, and constantly hit by radiation. Meanwhile, underground spaces are different. They're like natural shelters, protecting anything inside. That's what makes them some of the best places to look for signs of life on Mars. Interestingly, NASA is usually very careful when talking about life on other planets. Until now, most researchers have been focusing on tiny life forms like microbes, which might be hiding in frozen oceans on nearby planets and moons. But now, scientists really think this hole could lead to huge underground caves. If that's true, besides looking for signs of life, this spot could become a target for future astronauts, since the caves could turn into great shelters and even a Martian base. The photo with the hole isn't new. It was taken in 2017 by the Mars Reconnaissance Orbiter. In the image, we can see many holes scattered across the ground. The area basically looks like Swiss cheese. Most of the holes have dark, dusty ground under a thin layer of light-colored frozen carbon dioxide, aka dry ice. But one hole stands out from the rest. It's perfectly round, sits in the upper part of the image, and is about 328 feet wide. That's a massive opening. The hole also has a perfectly round crater around it. It's like something punched through the surface and left a ring behind. Scientists think it may have been caused by a meteor impact. Scientists believe Mars was much more like Earth billions of years ago, with better conditions for life. But today, the best chance of finding signs of life is underground. Mars no longer has a strong magnetic field or a thick atmosphere, so its surface is constantly blasted by harmful radiation from space. Underground caves or lava tubes act like natural bunkers, shielding anything inside from that radiation. This makes them the most promising places to search for life. Because of that protection, astronauts might one day find signs of past life there, or even fossils. To hunt for these hidden spaces, NASA brought in experts on underground structures and seismic activity from the U.S. Geological Survey. In 2019, they released a detailed map showing more than 1,000 possible cave entrances scattered all over Mars. There's a catch though. All of this data comes from spacecraft flying about 250 miles above the Martian surface. From that height, scientists can spot holes, but they can't see how deep they go or what's underneath. Some may be true caves, while others could just be shallow dents in the rock. Other missions, including the European Space Agency's Mars Express, have also found signs of ancient lava tubes beneath Mars's long-extinct volcanoes. But what makes this newly released image stand out is that it clearly shows at least one hole that appears to lead into an unknown underground layer. And if current plans come true, the earliest human astronauts could see this massive opening with their own eyes in the 2030s. And maybe they'll also be able to examine another Martian mystery. For more than 50 years, scientists have been puzzled by about 2 million dark streaks spread across the surface of Mars. These black marks look like long stains or shadows running downhill. It's almost like someone spilled ink on the planet. They were first spotted in the 1970s, and for decades, no one could explain what caused them. These marks are called slope streaks. They appear on steep slopes, crater walls, and ridges all over Mars. From far away, they look flat and dark. At first, scientists thought the streaks were caused by melting ice. This could create muddy landslides similar to wet dirt sliding down a hill on Earth. Even today, researchers still believe the streaks come from landslides, but not the kind involving water. New research using data from NASA's Mars Reconnaissance Orbiter shows that most of these streaks are caused by dry landslides. Instead of mud or water, it's loose dust suddenly slipping downhill, more like dry sand pouring off a pile when it gets disturbed. This explains how the streaks can form in Mars's cold, dry environment. One famous example is on Apollinaris Mons. It's an extinct volcano south of Mars's equator. On one side of a ridge, hundreds of streaks run side by side, which makes the surface look like a barcode. These streaks appeared sometime between 2013 and 2017. Scientists figured out a bit later that a nearby meteoroid impact could have triggered them. The impact didn't hit the ridge directly, but the shock shook the ground, and it was enough to send dust downhill. Now, because some streaks appeared after impacts, many scientists thought that meteoroids or Marsquakes were responsible for creating most slope streaks. But a new study shows that this idea is kinda wrong. The study in question looked at about 2.1 million slope streaks. They were photographed by NASA's Mars Reconnaissance Orbiter over a long period, from 2006 to 2024. Scientists have estimated that Mars has around 1.6 million slope streaks in total. But some streaks have been counted more than once because they appear in different image sets. So, after analyzing all this data, researchers have concluded that almost all new streaks form because of wind and dust, not impacts or quakes. Look, seasons change on Mars and winds slowly move dust and sand. When that loose material suddenly slips downhill, it leaves behind a dark streak. It's like brushing dust off a surface and revealing a darker layer underneath. Meteoroid impacts and Marsquakes do create some streaks too, but only in very specific spots. Overall, they play a very small role. Less than 0.1% of new slope streaks are caused by impacts and Marsquakes. The analysis has also shown that slope streaks are not spread evenly across Mars. They're grouped into 5 main regions. In each of these areas, new streaks usually form during times of the year when winds are strongest. There's a key tipping point called the dust movement threshold. Once winds get strong enough to lift and move dust, the loose material on slopes becomes unstable. When that happens, dust can suddenly slide downhill, creating a dark streak. This is similar to how strong winds on Mars can kick up dust and form spinning columns called dust devils. They're like small tornadoes moving across the planet's flat plains. One reason this mystery took so long to solve is that these streaks form when scientists can't easily see them happen. The conditions that create new streaks usually occur around sunrise and sunset. And because this phenomenon happens in low light, no spacecraft has directly watched a streak form in real time. The study also calculated how often new streaks appear. On average, about 0.5 new streaks form each year for every existing streak. And since Mars has around 1.6 million slope streaks, that's roughly 80,000 new streaks forming every year. Most streaks seem to stick around for several decades before they slowly fade away. However, scientists don't yet have enough long-term data to be completely sure. Another cool discovery: even though slope streaks cover less than 0.1% of Mars's surface, they may be one of the biggest sources of dust in the Martian atmosphere. In other words, these small-looking features may play a much larger role than we expected. That's why understanding how slope streaks move dust around Mars is important. Mars's dust affects weather, visibility, and even how much sunlight reaches the ground. That matters a lot for future human colonies, which would need stable conditions to survive and operate safely.
For thousands of years, people knew only about the planets Mercury, Venus, Mars, Jupiter, and Saturn, which they could see using simple telescopes, or even by the naked eye if conditions were good. But in the late 18th century, a famous astronomer named Sir William Herschel discovered a new planet that was icy blue in color. At first, people thought it was a star, but later they realized it was a planet. Today, we know it as Uranus, a planet that's more than 19 times farther away from the Sun than Earth. It's so far away that it takes Uranus 84 years to complete one trip around the Sun. This astronomer also discovered many other interesting things in space, like double stars and nebulae. In the mid-1800s, scientists noticed something pulled Uranus and strangely tugged its orbit. They thought there must be another planet out there, and they used math to predict where it would be. Finally, in 1846, they found Neptune using a telescope. It was too faint to see with the naked eye because it was too far away from the Sun. It was all so exciting. Who knows how many other planets could be there, lurking in the darkness of our solar system? Back in the mid-1800s, astronomers noticed something unusual was happening in the sky. A small rocky planet named Mercury was behaving strangely. It didn't follow the predictable orbit that was expected of it. One of the astronomers was a brilliant French scientist named Urbain Le Verrier. He came up with a theory that there could be another planet in our solar system no one had yet discovered. It would be located somewhere between Mercury and the Sun. This hypothetical planet, which he named Vulcan after the Roman god of fire, would have an incredibly hot surface, and it could be a potential explanation for Mercury's strange behavior. He never surely claimed Vulcan was really the one thing disturbing the orbit of Mercury. But, excited by the possibility of discovering a new planet, astronomers all over the world took the idea of Vulcan. For a planet that didn't exist, people committed to developing ideas and getting information about it. Some scientists didn't think it was likely that they had missed another planet as big as Mercury. It would have been hard not to see it by then. But there was a tiny chance of a smaller planet existing inside Mercury's orbit that was too close to the Sun, so no one could see it. One theory said it was about 13 million miles away from the Sun. Mercury is the planet with the most eccentric orbit in our solar system, but the closest point it gets to the Sun is about 28.5 million miles. This means Vulcan would be under half of that distance. The theory moved on, saying that if Vulcan existed, it would orbit the Sun every 19 days and 18 hours, and its path would be tilted about 12 degrees relative to the path of other planets in our solar system. Vulcan's position at its furthest point from the Sun would still be too close to the Sun to be seen with the naked eye, even during twilight. The only chance of seeing Vulcan would be during a solar eclipse, or when it passed in front of the Sun, which, as the theory said, would be 2 to 4 times a year. They had a theory that this mysterious planet was so close to the Sun that it could only be seen during a total solar eclipse when the Moon blocked out the Sun's blinding glare. So, every time there was an eclipse, scientists would peer at the Sun, hoping to catch a glimpse of Vulcan. They were trying really hard, but no matter what, they couldn't find this mysterious planet. Some astronomers claimed to have spotted it during eclipses, but no one could ever confirm or find evidence for that. the theory of Vulcan was left waiting for some better times. Einstein had a different idea. You know about his theory of general relativity, right? That's where he claimed gravity wasn't some sort of natural force, but a result of space-time curved because of the presence of giant space objects, like planets and stars. Planets circle around the sun in their usual orbit because space-time is curved. That means the planets are kind of falling towards the central star of our solar system. And Einstein tried to explain Mercury's unusual orbit using his own theory of relativity. Unlike the other planets in our solar system, Mercury's orbit wasn't that circular. Instead, it seemed to wobble slightly, as if there was an invisible force pulling it away. Einstein said this could be happening because the massive gravity of our sun was actually curving the fabric of space-time around it. He claimed it's possible this changed Mercury's orbit a little bit. It took the scientific community a while to test this theory, but it eventually seemed like the most plausible explanation. Even though Einstein's theory gave us a more elegant explanation for Mercury's strange orbit, some scientists were still holding out hope for Vulcan. It was especially hard to let go of the idea of Vulcan because Mercury is also the planet that's really hard to see from where we're standing. But later, more and more scientists started accepting Einstein's theory above their imagination. And they would observe a total solar eclipse specifically to test Einstein's theory of relativity, not because of Vulcan. And Vulcan is not the only hypothetical planet everyone was talking about. In the newer age, some believe there could be a mysterious planet lurking in the outer part of our solar system. But this one is more likely to exist. No one has seen it directly yet, but computer simulations show this so-called Planet 9, or Planet X, is probably somewhere there beyond Neptune. Neptune and Planet X could be similar in size. Planet X could be 10 times more massive than Earth and circles around our Sun in an elongated shape, which is on average 20 times farther from the Sun than Neptune. A year there may last between 10,000 to 20,000 Earth years. By comparison, a year on Neptune lasts 165 Earth years. Something this big moving out there beyond Neptune could explain the unusual orbits of smaller objects in the Kuiper Belt. The Kuiper Belt is the area of our solar system beyond Neptune and where it orbits. And there are most likely many asteroids, comets, and some other smaller bodies there, mostly made of ice. There was another hypothetical planet called Nibiru. Remember those rumors that the world could end back in 2012? One of the popular scenarios was Nibiru, which some claimed would hit our home planet at the end of the year. Of course, nothing happened. We're still here, all set and good, but the idea of Nibiru seemed interesting. Stories started in the 1970s when a man named Zecharia Sitchin mentioned Nibiru in his book, The 12th Planet, claiming it orbits the Sun every 3,600 years. But there's no chance a planet with such an eccentric orbit wouldn't disrupt other planets in our solar system with its gravity. And if it was really coming that close to Earth in 2012, we were supposed to be able to see it with the naked eye. Some simple calculations showed Nibiru would have been nearly as bright as Mars at its dimmest and brighter than the faintest stars you see from a city. Oh well, maybe we'll have more luck in the next 3,500 and something years. In 2011, a comet named Elenin appeared that many people thought could be Nibiru. But when you're looking at comets and planets through a telescope, you see they appear differently. A comet has a coma, which is a gas atmosphere, together with a tail, something a planet doesn't have. Plus, this comet didn't slam into the Earth. It came too close to our Sun and fell apart. The leftover pieces will continue moving on their way to the outer solar system for the next 12,000 years.
Attention, Earthlings. Yes, that would include you. Scientists have discovered a new member of the solar system. We officially have a new dwarf planet orbiting well beyond Neptune. But that's not all. Despite being small and unremarkable, This object, called 2017 OF201, I know it's a goofy name, might hold the key information about the speculated existence of Planet 9. Or, better said, it spoils the fun because instead of helping us find Planet 9, it could be the first tangible evidence that the theoretical ninth major planet was just that, a theory. But first, what exactly are dwarf planets? And why is this discovery so important? Well, in the early 21st century, researchers gained better telescopes and began discovering smaller, weirder celestial objects. It started with Eris in 2003, but the discovery of additional similar bodies led to Pluto losing its status as a, quote, true planet. To proudly carry the name of a planet, a space rock must check off 3 boxes. It must orbit the Sun, not another planet, like a moon would. It must be massive enough for its gravity to make it round. And it needs to be gravitationally dominant in its orbit. In other words, an object should be able to clear out most other objects in its path by absorbing them, slinging them away, or influencing them in some other way, like paying them off. Hey, just kidding. Imagine a giant, powerful truck driving in its own lane, pushing smaller cars aside. Hey, sounds like my commute. Although Pluto is orbiting the Sun and has the needed elliptical appearance, it's in the Kuiper Belt, a region full of icy objects. Because it can't clear its orbit, researchers realized that Pluto was not that different from many other similar bodies known as trans-Neptunian objects or TNOs. There are well over 5,000 known TNOs out there, with only 1,000 being officially numbered, meaning they've been studied enough to have their orbits confirmed. Now here's where it gets interesting. A while ago, scientists noted a pattern. Many of these minor planets shared similar paths and tilts. This inspired a theory that those objects were influenced by some still undiscovered Planet 9, also known as Planet X. The proposed super-Earth would have a mass 5 to 10 times greater than Earth's. It would orbit far on the outskirts, possibly as far as 500 astronomical units, and like an invisible puppeteer, manipulate the orbits of TNOs with its gravity. Some of these objects get classified as extreme trans-Neptunian objects. Let's just call them ETNOs for short. ETNOs are minor planets with an average distance of at least 150 astronomical units from the Sun. They have eccentric orbits, which can't be explained by the gravity of Neptune, Uranus, Saturn, or Jupiter. This led some scientists to conclude that Planet X must be out there. Ooh. As the years went by and more TNOs were discovered, scientists began to notice that those newly found objects didn't follow the previously established patterns. Many TNOs and ETNOs discovered in the last 5 to 6 years didn't match the same orbital parameters. Of the 6,000 objects found orbiting beyond 30 AU from the Sun, many show no signs of being influenced by a hidden planet. Well, despite that, scientists still hesitate to admit that Planet X is just wishful thinking. Not only is discovering something new exciting, but a planet like that could also protect us by pulling in asteroids from deep space. It could help explain why our solar system looks so different from many others, where super-Earths and mini-Neptunes are common. It might even solve how the solar system was formed, how objects got scattered, and what's still hiding in the dark. Discovering Planet 9 wouldn't just be cool, it could reshape everything we know about the solar system. However, with the discovery of 2017 OF201, actually that's still a mouthful, let's call it OFI from now on. With the discovery of OFI, the whole Planet 9 theory seems to be on its last legs. So, what makes OFI so special, and how does it affect the idea behind Planet 9? The newly discovered member of our solar system is estimated to be about 430 miles in diameter. This places it in the dwarf planet category, certainly larger than many other trans-Neptunian objects, but still about 1/3 the size of Pluto. What stands out most is its elongated orbit around the Sun. It takes at least 25,000 years to complete one revolution. Its orbit brings it as close as about 45 astronomical units from the Sun, which is similar to Pluto's distance, and extends out as far as 1600 AU at its most distant point. This means it travels far beyond the Kuiper Belt, and approaches the inner boundary of the Oort cloud. This orbit is not just extremely long, it's also highly eccentric, stretched out like a long oval. This puts it in a rare group of objects that travel to the most distant parts of our solar system. While there are objects with longer orbital periods, like comets that originate from the Oort cloud, they're much smaller than this newly discovered dwarf planet. But despite its relatively large size for such a distant object, Orphe is nearly undetectable. It spends most of its time hidden from Earth's view, far from the inner solar system and too faint for current telescopes to spot. In fact, astronomers estimate it's only visible for about 1% of its 25,000-year orbit. In fact, this new dwarf planet came closest to the Sun in 1930, the same year Pluto was discovered, yet it slipped away unnoticed. Nobody spotted it back then, and it only got discovered in May 2025 completely by accident. By digging through archived data from publicly available telescopes, researchers pieced together its location from 19 separate images taken over 7 years. That's impressive detective work. So, what does all of this mean for Planet X? The archive photos have revealed that this object's orbit does not match any of the orbital clustering previously used to support the Planet 9 hypothesis. It doesn't belong to the same group as other ETNOs, and, more importantly, if a hidden planet is really tugging on celestial bodies, Orphe should have been flung out of the solar system millions of years ago. If Planet 9 was where we speculated and had the predicted mass, then Orphe's current orbit wouldn't last. It would likely be altered or even destroyed within about 100 million years. However, its orbit appears stable and undisturbed, suggesting it has been like this for far longer. But wait, you exclaim. If the mysterious orbit of Orphe is not caused by an invisible giant planet, what else could it be? Well, space is full of surprises, and gravity isn't exclusive to planets. One idea is that the orbit has been stretched over time by galactic tides. Just like the Moon pulls on Earth's oceans, the Milky Way galaxy itself pulls ever so gently on everything in the solar system. It's a slow, steady force. But if you're far out enough, like Orphe is, even that gentle tug can twist your orbit over millions of years. Now, another possible explanation could be that a passing star may have come to our solar system a long time ago, especially during its formation. Back when the Sun was young and surrounded by newborn stars, one could have passed close enough to give some outer objects a gravitational nudge. That kind of flyby could have easily yanked an icy object into a stretched-out, tilted orbit. The third idea is that such unusual orbits are leftovers from the early solar system, when planets and debris were being flung all over the place. Some may have ended up in stable but extreme orbits, like Orphe, the dwarf planet. If something really is pulling on these distant objects from outside our solar system, something like the galaxy itself, then we lack models to explain it. It's remarkable that we've managed to spot Orphe in the first place. These objects only appear when close to the Sun, so we've likely seen just a fraction of what's out there. There could be hundreds or even thousands of similar rocks, all with strange orbits and mysterious origins. Which means the real mystery might not be a hidden planet, but the hidden world of space rocks quietly orbiting in the dark, waiting to be found. TRES-2b, or not to be, is a planet where night never ends. And it's not your regular night with stars shining in the beautiful skies. Here it's pitch dark and scorching hot. TRES-2b is a gas giant, roughly 1.5 times more massive than Jupiter, and its surface absorbs light better than charcoal. It might also have a faint dark red glow because of its burning air, which is as hot as fresh lava. Lovely. In the star system of 55 Cancri, there are 5 planets, 4 of which are gas giants similar to Jupiter and Saturn. But the 5th one, or rather the first because it's closest to the star, is different in a most horrible way. 55 Cancri e is so close to its sun that half the planet's surface is a literal ocean of molten lava. The other half is in eternal darkness because it never sees the sun. The planet is always turned to its star on one side, and between the scorching and the dark, there's the twilight zone, a thin strip of gloomy nothingness. That's a getaway spot. HD 189377b, oh, I'm not going to say that again, is the only exoplanet in the orbit of its star, and at first glance it looks quite pretty, blue and white swirls making up wondrous patterns on the surface. But these pleasant colors actually come from hard silicate particles in the planet's atmosphere, which means it rains glass here. But the worst is that winds reach the speed of 5,400 miles per hour, or almost Mach 7. Well, for comparison, the fastest wind speed on Earth was 254 miles per hour, over 20 times less. Thus, the glass falling from the sky travels horizontally at hypersonic speeds, shredding everything in its path. Better duck. The next system, whose name I won't even try to pronounce, this one, has 3 exoplanets, which are all being slowly destroyed by their own star. It happens because that star is not a regular. It's a pulsar, a rapidly spinning core of an exploded star. It creates powerful electromagnetic pulses in several directions while rotating at several thousand times per second. As a result, the planets orbiting this deceased star are slowly being eaten away and will eventually disappear entirely. Kepler-70, hey, I can say that one, is a hot blue dwarf star that exploded into a red giant some 18 million years ago. At the time, it was orbited by at least 2 planets, the closer of which was a Jupiter-like gas giant. Its name was Kepler-70b, and it still exists, but the overgrown star consumed it and transformed it into a blazing hot rocky world. Right now, it's one of the hottest planets ever discovered. Its temperature is higher than the surface of our Sun. It was lucky to survive spending time inside the star, but it's evaporating now and will probably be no more in the near future. WASP-12b is one of the weirdest and saddest planets out there. The enormous gravity of its star, combined with the planets consisting mostly of gas, result in the star slowly devouring its protege. So pal, what's eating you? My mother. WASP-12b has already taken the form of an egg, stretched toward its merciless sun, and it's unable to do anything with its condition. In another 10 million years, the planet will inevitably succumb to the voracious star's appetite. Hey, you asked. If you ever wondered what it's like to walk on ice and hot coals at the same time, Gliese 436b is a planet that would give you a vivid example. Being extremely close to its sun, the Neptune-sized exoplanet boasts temperatures hotter than a blazing oven, and yet it's covered in ice, which burns incessantly. This ice is much denser due to the enormous gravity of the planet, staying solid even under extreme conditions and not melting away. No list of frightening worlds could do without mentioning Venus, the Earth's evil twin. The second planet from the Sun has an atmosphere so thick and full of clouds that its surface is much hotter than that of Mercury. Volcanic eruptions constantly thrash Venus. Its gravity is almost 100 times stronger than ours, and those clouds I mentioned are not made of water but of sulfuric acid, which condenses and rains down on the ground, adding to the inferno. But even if you were brave, or crazy, enough to try to pass through these clouds, you probably couldn't. The winds up there are as strong as some of the most powerful hurricanes back on Earth. Here we have a very long name for a very, very cold planet. Although the host star is not too far away, it's a small and rather cool red dwarf, whose light and heat barely even reach the planet. The temperatures out there fall as low as minus 370 degrees, which is only marginally warmer than absolute zero. The exoplanet is thus dark, gloomy, and covered in eternal ice that never thaws. I thought I thaw that somewhere. Still, if it has a rocky core, it might generate some heat, so there's a chance that deep below the frozen surface, some unknown alien things might lurk. Dimidium, located roughly 50 light-years away from our solar system, is a planet hostile to any living thing on many accounts. It's tidally locked to its sun, which means one of its sides is always facing the star, while the other is always turned away. The hot side is heated to over 1,800 degrees, perpetually blown over with winds reaching 600 miles per hour. And that's winter. Well, actually, I don't know that. Despite Dimidium being a gas giant, it has a large amount of iron in it, which melts and evaporates in the atmosphere, creating clouds. And when those cool down, they fall on the surface in the infernal rain of molten iron. That'll test your mettle. Oxygen is usually viewed as an element that might bring life to a planet, but this is definitely not the case for Osiris. Scientists were shocked to find oxygen on this planet, or rather around it, because it's 8 times closer to its star than Mercury is to the Sun. This extreme distance makes Osiris a living melting pot, where anything that could burn will. It's also responsible for a very short orbit of the planet around the star. A year on Osiris is just 3.5 days on Earth. To boot, the atmosphere of the planet is constantly blown and melted away by the heat from its sun. Vacation? Nah, let's keep looking. Karat XO 3b is neither as hot nor as cold as some of the others on this list, but it's terrifying in its own more insidious way. It's a gas giant similar in size to Jupiter, yet 20 times denser. This makes this exoplanet's gravity weigh down on everything on its surface 50 times more than it would on Earth. Stepping on it would be your ultimate doom, because you'd be immediately crushed by the density of its atmosphere. Karat 7b is another oven-like world. Its day-to-day temperature is over 4,000 degrees. Combined with the rocky surface, it presents an infernal landscape. The rocks on the ground bubble and boil, evaporating in the atmosphere, where they cool down and eventually fall back on the surface in a brimstone rain. The saddest thing about Karat 7b is that it might have once been a gas giant whose atmosphere melted away from the heat, leaving only the scorched core. So, we might be getting closer to finding a massive icy planet beyond Neptune's orbit. Sorry Pluto, still not you. Recently, some universe mapping using data from a telescope in Hawaii eliminated about 78% of the possible locations for this mysterious Waldo from space. Some people call it Planet 9, while others prefer Planet X. Either way, it's been causing controversy since its existence was first proposed, and that is mainly because no study so far can answer the big question: does it really exist? If discovered, Planet 9 would rank as the 5th largest planet in our solar system, with a mass 10 times that of Earth. It's also theorized to be gaseous, like Uranus. The initial study on Planet 9, dating back to 2016, suggests that this colossal new planet orbits the Sun 29 times farther out than Neptune, which sits at about 2.8 billion miles. As a result, the Planet 9 would take between 10,000 and 20,000 years to complete a single orbit around the Sun. If confirmed, this yet-to-be-understood world would dominate a region larger than any other known planet in our cosmic neighborhood. These are all intriguing hypotheses, but without a single piece of evidence or observation to back them up. Before dismissing this as a wild guess, it is important to note that these researchers relied on complex mathematical modeling and computer simulations to speculate about the planet's characteristics, because that's what they do. The hypothetical presence of this planet would explain various mysterious features located beyond Neptune. We are specifically talking about the Kuiper Belt, a huge donut-shaped region filled with icy debris left over from the formation of the solar system, including comets and dwarf planets like Pluto. What happens is that the 6 farthest objects in the Kuiper Belt exhibit elliptical orbits that are all oriented in a similar direction within physical space and tilted approximately 30 degrees downward relative to the orbital plane of our 8 known planets. What's strange here is that, despite their distinct orbital velocities around the solar system, they maintain this alignment. The likelihood of such alignment occurring randomly is extremely low, around 0.007%. So, here comes Planet 9, a hypothetical massive celestial body that offers a plausible explanation for this strange phenomenon, potentially exerting gravitational influence to shape these orbits. The initial theory didn't hold up for long, facing accusations of observational bias and calculation errors. Then, in 2017, another study popped up, sparking back the idea that maybe Planet 9 is out there after all. This time, Spanish astronomers tried a novel approach, focusing on observing extreme trans-Neptunian objects. These celestial bodies orbit the Sun in highly stretched elliptical paths, with average distances exceeding 13 billion miles. The research suggests that the distances between these objects' nodes and the Sun might provide clues to Planet 9's location. You see, these nodes are the points where a celestial body's orbit intersects the solar system's plane. When these objects reach these points, they're more likely to interact with other solar system bodies, potentially causing significant changes in their orbits or even collisions. So, if the trajectory of these extreme trans-Neptunian objects remains stable, everything's fine. But if it's not, well, that's a sign that something else, something big, is messing with their path. And that's exactly what the research found. There is something unseen out there, throwing these objects off course. And that something could be a planet, chilling at a distance between 300 to 400 times farther from the Sun than Earth. To this day, the study of the extreme trans-Neptunian objects is the strongest evidence we've got for Planet 9's existence. And if you're still not convinced by this theory, know that strange motions like these have led to planetary discoveries before. Neptune, for instance, was spotted because Uranus's motion didn't quite agree with the predictions of Newtonian gravity. But the deflection of its orbit could be explained if it was caused by a pull of an undiscovered planet. And just like that, we discovered Neptune. Now, the year is 2021, and there's all this buzz about Planet 9 again. After correcting some old guesses, studies are now leaning towards the idea that this mystery world follows an epic loop around the Sun every 7,000 years. That is massive news, because it means this planet might be closer than we ever thought, making it easier for our telescopes to spot it. The paper also suggests there is a whopping 99% chance that the funky orbits of these distant objects are all because of this unseen planet, not just some cosmic coincidence. Now, the odds of this whole situation being a fluke are down to a 1 in 250 chance, which is much better than the 1 in 10,000 chance back in 2016. All these optimistic numbers have brought us to where we are today, keeping our hopes and working on better equipment to continue the mission of spotting Planet 9. As mentioned earlier, researchers in Hawaii created some kind of treasure map utilizing the Panoramic Survey Telescope and Rapid Response System to eliminate 78% of its locations. This is great news, considering how challenging it is to find a planet-sized needle in a cosmic haystack. But unfortunately, Planet 9's presence remains a ghost in the dark outer reaches of our solar system. Enthusiasts are still convinced of its existence and believe it is only a matter of time before we celebrate the discovery of Earth's new cosmic cousin. They're putting their hopes on the Vera C. Rubin Observatory, which is currently under construction in Chile and is scheduled to begin science operations in late 2025. Over the course of 10 years, this observatory will scan the entire southern hemisphere sky every few nights with a 27-foot, fast-moving telescope equipped with the largest digital camera in the world. The idea is to catalog everything in the solar system, reaching out to and beyond Neptune, and tracking the movements of millions of celestial objects, including space junk, asteroids, comets, and stars. If Planet 9 is indeed out there, this next-generation telescope could be the one to find it. The existence of this mysterious planet is far from being universally accepted in the scientific community. That is simply because Planet 9 isn't the only explanation for the strange phenomenon occurring beyond Neptune. One theory suggests that a group of distant objects, such as dwarf planets, comets, and moons, might be collectively influencing the orbits of the extreme trans-Neptunian objects. Others believe that a black hole is behind all this. These compressed masses are some of the densest objects in the universe, potentially capable of affecting the orbits of other masses, like how this supposed ghost Planet 9 is believed to be doing. Another bold perspective suggests that our current understanding of the laws of gravity is flawed, actually incomplete. This theory, known as modified Newtonian dynamics, proposes that these distant icy objects exhibit strange behavior not due to influence from another planet, but rather because the immense gravitational field of the Milky Way is influencing them. However, even supporters of this theory acknowledge that it is too early to draw firm conclusions, and much more extensive research is still required. While we continue our relentless hunt for Planet 9, some astronomers have taken it a step further, suggesting the existence of a hypothetical Planet 10. This world has a mass and size like that of Mars or Earth and is located on the edges of the Kuiper Belt. But the thing is, if this alleged Planet 10 is indeed as small as scientists believe, it might not have enough gravity to clear its orbit of debris. And that is pretty similar to what happens with Pluto, being one of the reasons why it got into trouble back in 2006. So yeah, it's better not to get too excited. This supposed Planet 10 might end up classified as another dwarf planet.
When you explode planets, things get red hot. Atmospheres are stripped away. Stuff is flying apart. Everything collapses. The world becomes brighter than a dozen suns. You squeeze your eyes shut and cover your ears. Your hair stands on end. The sheer power of a cosmic blast is terrifying. Some time before the explosion, you're hovering in almost complete darkness. Below, you see the moon, or what you think looks like the moon. The surface of this light-colored sphere is pockmarked with craters left by meteorites. You see huge, steep hills stretching for miles. It's Mercury. And right now, you're going to explode it. As if in slow-mo, you watch the planet fall apart. And then, in the blink of an eye, you see a wall of debris closing in on you. First, giant chunks of rock. Those are all that's left of the planet's solid crust and rocky mantle. The appearance and structure of the debris flying in your direction changes. Now, the stuff looks liquid, like splashes of quicksilver. That's Mercury's metallic core bursting apart. It used to take up 85% of the planet's volume. And finally, it's a firework of solid pieces again. It's the planet's solid core. The explosion is so powerful, it knocks Earth into a different orbit. The sun hiccups and swallows down an enormous cloud of dust. That's everything Mercury has left behind. But don't worry, our solar system won't lose any planets. This whole explosion thing is only a temporary experiment. Once you're done watching the show, you press another button, and the planet gets back together, as if you've hit rewind. You approach the next planet on your way. Its surface is hiding under a super dense atmosphere made up of carbon dioxide. If you decided to land on Venus, you'd watch thick clouds of sulfuric acid pass by. You'd see the planet's surface, reddish-brown, dry, and incredibly hot. You'd probably walk across flat, smooth plains, covering 2/3 of the planet's surface. You'd gawk at volcanoes littering Venus, all 1,600 of them. Unfortunately, you won't be able to do that because you press the button. Boom! Huge chunks of basalt fly away from the center of the explosion. That used to be the planet's 12-mile thick crust. Then you spot bright burning meteors flying towards you at incredible speed. Those are chunks of Venus's molten rocky mantle. The fire rain seems endless, maybe because the mantle was 1,200 miles thick. But that's not the most massive part of the planet. The power of the explosion forces apart Venus's metallic iron core. This core used to be twice as wide as the mantle. You reach the blue marble of your home planet. What will its insides look like, scattered in space? From above, Earth looks pretty. 71% of its surface is blue, because of all that water, seas and oceans. There are also areas of green, yellow, and brown and white swirls. You press the button. The planet bursts apart in a hailstorm of rocks. They're what's left from Earth's thin crust and much, much thicker mantle. It used to take up nearly 84% of the entire planet's volume. You see the rocky rain change into something way more liquid. It's scorching hot iron and nickel that used to make up Earth's outer core. The metals weren't under enough pressure to be solid. The bang is so powerful that it takes apart Earth's inner core. It used to be a solid ball of iron and nickel. After the pieces fly apart, they follow their own orbits around the sun. The most massive chunks crash into the moon, and some travel further and get swallowed by our star. You can't linger. The red planet is waiting for you. The surface of Mars is covered with rusty-colored dust. The thickness of the dust layer varies from area to area, but in most places, it's 7 feet thick. The ground is colored gold, brown, tan, and even greenish. The hue depends on the minerals that make up the soil. The planet's surface is rocky. It's covered with dry lake beds, craters, volcanoes, and canyons. Bang! Mars is a rocky planet. You have to dodge mountain-sized chunks of crust made up of volcanic basalt rock. What you see next looks as if you've blown up huge amounts of soft, rocky toothpaste. That used to be Mars's mantle, composed of oxygen, silicates, and other minerals. And then the flying pieces get solid again. It's the planet's core's turn. It was solid, made mostly of iron, nickel, and sulfur. Billions and trillions of fragments of all sizes, from a small moon to pieces several feet wide, get launched in all directions. But only very few parts have enough momentum to leave the solar system. The whole event slightly changes Earth's orbit, and the temperature on our planet goes up by 18 degrees Fahrenheit. You leave rocky planets behind and close in on the first gas giant on your way. It's Jupiter. Thick brown, yellow, red, and white clouds hide its surface. They make the planet look colorful and beautifully striped. You hit the button. This time the view is different. Instead of chunks of solid crust, you see jet streams of gas accelerating from the planet's center. It's what used to be Jupiter's atmosphere, made up of hydrogen and helium gas. In no time, the matter hurtling away to space turns liquid. That's hydrogen changing its form under immense atmospheric pressure closer to the center of the planet. A bit later, the liquid is already a mixture of metallic hydrogen and helium. And finally, something solid. It was probably Jupiter's core, 14 to 18 times the mass of Earth. The gas giant's diameter was about 90,000 miles, but the blast lasts no more than half a second. The explosion of Jupiter is so strong, it evaporates smaller planets like Mars and Earth. The sun remains pretty much untouched. It gets hotter and kinda unstable for a bit, but it doesn't last long. The next gas giant on your way is Saturn. At first sight, it looks as if the planet has a surface. The seemingly solid yellowish-brown sphere is surrounded by layers of clouds. Saturn's trademark rings are awesome and colorful, gray, beige, and tan. They're actually groups of tiny ringlets that are made up of floating chunks of water, ice, rocks, and dust. These chunks range in size from specks to massive skyscraper-sized pieces. While orbiting Saturn, they keep colliding, and larger pieces get shattered. You're surprised to see that the rings aren't perfectly round. They have bends caused by the gravitational pull from the nearby moons. 53 of them are confirmed. Titan, an icy world bigger than our moon and even Mercury, is the largest. What you see looks eerily similar to what happened when you exploded Jupiter. There's only one difference. Saturn's rings break apart, sending rocks and ice flying into space at incredible speed. The largest pieces crash with the planet's moons, wiping away the smallest of them. You see streams of gas, mostly hydrogen and helium, with a bit of methane, ammonia, and water. They're moving at breakneck speed away from where the center of the planet used to be. After that, splashes of liquid matter. That's liquid hydrogen that later turns metallic. And finally, the chunks of the solid core made up of rocky materials. You're looking at a beautiful blue-green sphere of the ice giant Uranus. The planet gets this unusual hue when the light from the sun gets reflected off the planet's surface. Plus, Uranus's atmosphere is mostly hydrogen and helium, with traces of methane gas that absorb the red light. Anyway, bang! This time, it's massive blobs of ice that are hurtling in your direction first. They used to be the part of the planet's ice mantle that once made up 80% of the planet's volume. But why does this ice look liquid? On Uranus, frozen liquid isn't solid like on Earth. Ice is a hot, dense fluid made up of water, ammonia ice, and methane. It's often called the water-ammonia ocean. After the bizarre ice rain, you see solid pieces of the planet's rocky core. It used to be small, no more than half the Earth's mass. Some of Uranus's moons get pulverized in the explosion, and several even get ejected out of the solar system. The explosion also slightly shifts Neptune's orbit. And the last planet on your way, Neptune. It looks blue because of a layer of swirling gas and permanent clouds. No time to linger. Boom! The planet doesn't have a solid surface. That's why, after pressing the button, you see Neptune's liquid mantle bursting. It looks like a water-filled balloon thrown down from the 50th floor. This sends splashes of water, ammonia, and methane ices away into space. It's followed by lava-like remains of the planet's mantle. It used to be liquid, red-hot, and rich in methane, ammonia, and water. That's what's left from Neptune's solid core, made up of iron and other metals.
A new super-Earth has been spotted by astronomers, and it's quite intriguing. This planet, called TOI 715b, is about 1.5 the size of Earth, which is why it's called the super-Earth. It's also relatively close to us in space terms, only 137 light-years away. For comparison, most exoplanets are hundreds of light-years away, and all the interesting stuff, like black holes and nebulas, are usually more than thousands of light-years away from us. So, could it be habitable? The habitable zone is an estimate of where a planet might have the right conditions for liquid water. This is what we call some distance from the star, where the temperatures on the planet should be okay-ish, and water should stay liquid on its surface. It's not super precise, because it depends on a bunch of factors like the type of star, how reflective the planet is, its size, and so on. Also, just being in this zone isn't enough for water to actually be there. The planet also needs the right kind of atmosphere and a few other things. So, we invented a stricter definition in 2014, the conservative habitable zone. It's a more precise term defining the best candidates that have liquid water. Otherwise, we get too many potentially habitable planets that are not actually habitable at all. The CHZ is based on how much energy a planet gets from its star compared to Earth. If a rocky planet gets between 40 to 85%, it's considered to be in the CHZ, no matter how far away it is from its star. These planets have a higher chance of being habitable. And yes, TOI 715b is located there. This super-Earth orbits the M-type star, also called red dwarf. It's a star that's much smaller and cooler than our Sun, about a quarter of the Sun's size and mass. But if the planet is located in the habitable zone, it's actually a better option for life. Red dwarfs live much longer than our Sun, a yellow dwarf. This also means that they have more time to form little creatures on their planets. And this red dwarf really is older than our star. Our Sun is 4.6 billion years old, and this star is 6.6 billion years old, give or take a few hundred million. It doesn't have much magnetic activity, so it's not dangerous. It doesn't flare up like younger red dwarfs. These flares can be super strong and might even hurt planets by taking away their atmospheres. Although some planets around it do have thinner atmospheres, it seems like this red dwarf has already gone all out. These red dwarfs are where we're looking for planets that could support life right now. Our super-Earth is really close to its star, zooming around it in just 19 days. Since the star is small and the planet is so close, the planet passing in front of its star happens a lot and looks really clear. This makes it easy for telescopes like the James Webb to study its atmosphere without needing too much time. Now, speaking of the James Webb Space Telescope, It's bringing us into a new era of understanding distant planets beyond our solar system. Imagine being able to see what gases make up the air on a planet millions of light years away. James Webb will help us to find worlds that could support life. Right now, it's trying to figure out whether TOI 715b has an atmosphere. If it does, its atmosphere might be easier to spot compared to a planet that's drier and denser. And then we might get even more height because it would look like a good place for life. On top of all that, there might be another planet in this system, also in the habitable zone. We're not sure whether it's really there, it's just a candidate with a crazy name. But if it turns out to be real, it would be about the size of Earth. Also, it would be the smallest planet in the habitable zone ever spotted by the TESS telescope. Now, another cool thing about TOI 715b is that it cannot just have water on it, but be an entire water world. An ocean planet is a type of planet that has an ocean covering its surface or has subsurface oceans. They might not have much dry land because the water can cover everything. Sometimes the entire planet can be covered in other liquids, like lava or ammonia. When it comes to planets outside our solar system, we can't see surface water directly with our current technology. Instead, scientists look for water vapor in the atmosphere as a hint there might be liquid water below. And of course, we wonder if these planets can have life, hopefully not in the form of Leviathan-like monsters. Our models show that planets with oceans might be pretty common in our galaxy. This means there could be lots of ocean worlds out there waiting to be discovered. But the most important part about TOI 715b is that it's in the so-called small planet radius gap. If we give the planets a lineup, there will be those that are bigger and smaller than Earth. But there's a sudden gap in planets that are about from 1.5 to 2 times bigger than ours. Where are they? This gap is interesting to scientists because it tells us something about how planets form and change over time. It's not that planets don't form in this size range. They actually start off larger and then lose some of their mass, like a balloon gradually deflating. Perhaps it happens because of how they orbit their stars, with stars blowing away some of their mass as they dance around it, as our Sun does with gas from comet tails. This gap holds a lot of mystery, and planets, like our new super-Earth, are clues that could help us unravel it. We aren't sure whether it exists around red dwarfs. Maybe it's a gap in how dense these planets are, rather than in their actual size. So studying our discovered planet is even more interesting. It'll help us learn more about distant stars and their planets. Now, I mentioned TESS a while back. NASA's TESS, Transiting Exoplanet Survey Satellite, has been in space for 6 years now and has been incredibly successful. NASA launched TESS because we already found over 5,000 planets orbiting other stars, mainly thanks to the Kepler telescope. But Kepler mostly found large planets, not necessarily like Earth. We decided to focus TESS on finding smaller Earth-like planets around nearby bright stars, making them easier to study with future telescopes. Here's how it works. The camera observes stars and looks for changes in their brightness. If the brightness suddenly drops for a while and then gets back, it could mean there is a planet passing in front of it. But stars can dim for other reasons too. For example, flaring up or having dark spots on their surface, which is why we need to be careful with this data. TESS shows us the size and orbit of these planets. Then ground telescopes help determine their mass. With these 3 parameters, we can figure out what the planets are made of and if they're rocky like Earth or gassy like Jupiter. Yeah, you want to avoid Jupiter after taco night. One example of TESS's discoveries was the TOI 700 system. There, it discovered its first ever Earth-like planet, TOI 700d. This exoplanet also orbited a red dwarf, and it's even closer to us, about 100 light-years away. Unfortunately, it's unlikely to be habitable because the temperatures there are crazy. Another big discovery was made in the AU microscopy system. TESS discovered a planet about 4 times the size of Earth and another nearly 3 times Earth's size. This system has become a key area for studying how stars and planets form and change over time. TESS has also spotted a variety of other exciting finds, including supernova, hot worlds, and so on. And as it enters its 6th year, we can only expect more exciting findings to come.
How about a mysterious object that used to orbit between Mars and Jupiter? At one point in the early days of the solar system, it was destroyed by some catastrophic event. This space body is called Phaeton, and this planet is totally hypothetical. But some people believe that the debris the planet left behind could have formed the asteroid belt. If you like this kind of content, please give it a non-hypothetical like and subscribe. Your support is very important to us. Thank you. Now, at the start of the 19th century, people hadn't discovered the asteroid belt yet. But in 1801, one astronomer spotted the largest asteroid in our solar system, Ceres. At that time, it was believed that a planet was orbiting between Mars and Jupiter, and Ceres seemed to be a suitable candidate. But the next year, another astronomer discovered one more space object with a similar orbit. It was an asteroid that was later named Pallas. These discoveries made scientists conclude that these two objects could have been fragments of the very planet that had once been dwelling between Mars and Jupiter. The following discovery of two more asteroids, Juno and Vesta, seemed to confirm this idea. Only in the 20th century did the hypothetical planet get its name, Phaeton. It was actually a name taken from Greek mythology, meaning shining one. The hero with this name was the son of the sun deity, Helios, who rode his solar chariot across the sky every day, giving humans the heat and light necessary for survival. One day, Helios allowed Phaeton to drive his chariot. But the sun didn't manage to control the horses. Everything went wrong, and Earth was about to burn down. That's why the main deity, Zeus, had to stop Phaeton with a thunderbolt. The idea of the asteroid belt being the sad result of the planet's destruction was called the disruption theory. And of course, there were several ideas explaining the planet's tragic fate. The most obvious one is that Phaeton was hit by a large space object. It could be another hypothetical body called Nemesis. Some people believe that it's our sun's companion star. According to this theory, the sun has a small companion star that has an extremely elliptical orbit. This orbit periodically brings it close to the Oort cloud, a large sphere of icy objects surrounding the sun. This, in turn, causes a lot of mess. It might be the reason why this hypothetical companion star was also nicknamed the Death Star. It might be a red or brown dwarf. But whatever it is at the furthest point of its orbit, it's believed to be about 1.5 light-years away. The search for this star has been in progress for decades, but no one has succeeded in locating this elusive and potentially non-existent space object. Anyway, back to Phaeton. Another theory claims that the planet could have suffered some internal cataclysm which tore it apart. But these days, the disruption theory has fallen out of favor. It was replaced by the accretion theory. According to it, the asteroid belt formed in the process of gradual buildup of particles initially floating in a gaseous environment. With time, they came together to create larger masses. Gravity pulled on these particles, encouraging them to stay together and form planetesimals, tiny planet-like bodies that later form real planets. Planetesimals kept colliding with one another, eventually developing into protoplanets. Such protoplanets grow until they form planetary bodies. As the mass of objects increases, the gravitational forces acting between particles become stronger too, continuing to build gas, dust, and ice within the nebular disk. It all has a snowball effect where the increase in mass results in more particles getting involved in the process. Eventually, there's no building material left, and large space objects float in the darkness of space. Now, many experts think that the asteroid belt is the remains of the protoplanetary disk which had once been orbiting the Sun before the planets formed. Unfortunately, it never had a chance to coalesce into a planet because Jupiter's gravitational effect prevented it from happening. In any case, even though Phaeton's was a good story, it's not popular anymore.
So, astronomers have just announced that they might have found signs of possible life on a planet outside our solar system. Wow! This distant world is called K2-18b, and it sits about 124 light-years away in the Leo constellation. So, what life are we talking about? Little green men? Octopus-like tentacled creatures? Well, not exactly. First things first, let's define what life is. It's what distinguishes animals and plants from inorganic matter, like the ability to grow, reproduce, and change. Now, what do we need to support life? If what comes to your mind is water, bingo! Scientists have the feeling that K2-18b might be covered in oceans, and if it's so, it can support tiny forms of life like microbes. A team of researchers from the UK and the US used the James Webb Space Telescope to look at the planet's atmosphere. They found hints of two very special chemicals. On Earth, only living things can produce those, and the living things I'm talking about are mostly tiny ocean plants called phytoplankton. So, basically, this planet might indeed host life in the form of algae. Now, of course, scientists still need more proof before getting too excited. We should keep in mind that it's possible that those chemicals were made by something we don't understand yet, not necessarily by living things. But still. K2-18b is a big boy. It's more than 8 times heavier than Earth and about 2.5 times larger. So what makes it even more interesting is that it's located in the Goldilocks zone around its star. That means it's not too hot and not too cold there, just right for the existence of liquid water, which is highly important for life as we know it. Astronomers study faraway planets like this by watching how their light changes when they pass in front of their star. This allows us to figure out what kinds of gases are in the planet's atmosphere. Back in 2013, the James Webb Space Telescope found methane and carbon dioxide in the atmosphere of the planet. These are carbon-based molecules, and it was the first time they were found on a planet in the habitable zone. Scientists also saw a weak signal of a chemical called DMS, which is mostly made by tiny ocean life here on Earth. So, the researchers pointed the telescope at the planet again a year later using a different tool that could pick up more light details. This time, they found much stronger signs of DMS and some related chemicals. But the problem is the signals aren't strong enough yet. They haven't reached something called the 5 sigma level, a parameter scientists use to confirm discoveries. Plus, even if the DMS really is there, it doesn't automatically equal the existence of life. Scientists once found DMS on a comet, which means that it can be produced without some kind of life taking part in the process. And still, the amount of DMS on K2-18b looks way higher than anything seen on Earth. That's why some astronomers are sure it's coming from something living. K2-18b has been a top pick for what scientists call a Haitian planet. This term means a big, watery world with thick hydrogen atmosphere. It's not the kind of place where extraterrestrial civilizations like in movies would live. But it could be home to tiny life forms, like the microbes that once lived in Earth's oceans billions of years ago. Once again, not everyone agrees on how friendly K2-18b really is for life. Some scientists think planets like this might actually be too close to their stars to hold on to liquid water. K2-18b orbits its star every 33 days, which is pretty fast, and could mean it's too hot. That's why some experts claim that even if the planet has any water at all, it might be boiling. Or maybe it's not water, but oceans of lava. But most scientists agree on one thing: we should wait and see. With just 16 to 24 more hours of telescope time, astronomers could confirm what they've seen. This could happen in the next few years. And even if it turns out K2-18b isn't the world we're looking for, we're still getting close. With powerful telescopes like James Webb and more coming in the future, we might be able to answer whether we're alone in the universe or not. At the same time, some places in our own solar system, like Mars, Venus, or Saturn's moon Enceladus, might actually have a better shot at hosting life. Or we could keep exploring other promising worlds, like Proxima Centauri b, which is the closest exoplanet we know about. It's just 4.25 light-years away from us and orbits a small star called Proxima Centauri, right in the habitable zone. This planet is a bit bigger than Earth, which makes it a super-Earth. That's what we call exoplanets larger than ours but much smaller than gas giants like Neptune or Jupiter. Proxima Centauri b is a fast-moving world. It needs a mere 11 days to go all the way around its star. Scientists think Proxima Centauri b might have a rocky surface, and that's a good sign for possible life. On the other hand, its star blasts it with a lot of ultraviolet radiation. It might have already destroyed the planet's atmosphere, if there was any to begin with. So there's a big question mark when it comes to this world's habitability. Then we've got TRAPPIST-1e, another promising Earth-like planet. It's one of 7 rocky planets orbiting a small, cool star called TRAPPIST-1, about 39 light-years away. Discovered in 2017, it might be one of the most promising places to look for life beyond Earth. This planet is actually a bit smaller than Earth, with a mass around 1/2 that of our planet. It completes an orbit around its star in just 6 days, which is super fast compared to Earth's 365 days. The planet's size and density suggests it has a rocky surface, and that's another key factor when we talk about habitability. Even though TRAPPIST-1e is very close to its star, the star is quite dim and cool, so the planet might still have a stable Earth-like climate. Some scientists even think it could have more water than Earth. Let's move on to Kepler-186f, located about 500 light-years away. It was the first Earth-sized planet found in a habitable zone of another star. It orbits a red dwarf, which burns cooler and lives much longer than our Sun. This means Kepler-186f could have stable conditions for billions of years, giving life plenty of time to possibly form and evolve. The planet gets only about 1/3 of the sunlight Earth receives, so it would likely be cooler but still warm enough to keep water from freezing. It also seems to be a rocky planet just like Earth, which boosts its chance of hosting life. Now, how about visiting LHS 1140b, about 40 light-years away? This planet has about 5.5 times the mass of Earth. Scientists think it's rocky and possibly has a thick atmosphere, which is a big deal. An atmosphere like that can trap heat, keep temperature stable, and protect water from escaping into space. This world orbits a quiet red dwarf star, so it's not constantly blasted by harmful flares like some other exoplanets are. Some studies even suggest LHS 1140b could be an ocean world with lots of water. So it's one of the more exciting planets we've found in our neighborhood. And finally, we have Gliese 12b. Astronomers call it Exo-Venus. It sits 40 light-years away from Earth. This world is about the size of Venus and orbits a cool red dwarf star. It needs just under 13 days to complete one orbit. The temperature on the planet is around 107 degrees, which is quite warm but still okay for life. The thing that makes Gliese 12b so interesting is that it could help us understand how Earth-sized planets around cool stars hold on to their atmospheres. That's important because an atmosphere is crucial for things like liquid water and protecting life from harmful radiation. According to some researchers, Gliese 12b is one of the best chances we have to figure out whether planets like this can stay habitable.
NASA sent a spacecraft right into the Sun. It's the fastest human-made object ever, and could cover the distance from Philadelphia to Washington, D.C. in just 1 second. The Parker Solar Probe's mission is to study our star's dangerous behavior. Scientists warn that massive solar storms are inevitable, and the consequences could be catastrophic for our planet. The spacecraft got 7 times closer to the Sun than any other probe ever did. It managed to do so during its 20-second flyby to the star since its launch in 2018. Because our star is so massive, its gravity is really strong, like a giant magnet. As the probe flies around the Sun, it uses gravity to go faster and faster and eventually picks up that crazy speed. As it got closer and closer to the Sun's corona, which is its outer atmosphere, the probe had to survive temperatures of 2,552 degrees Fahrenheit. That's hot enough to melt many metals. It was protected from that heat and radiation by a 4.5-inch thick carbon shield. It kept the tools inside the probe safe and running at around room temperature. The scientists went to all this effort because they're hoping to solve a big mystery about the Sun that's been puzzling them for ages. The surface of our main star is already super hot, but as you move closer out to the corona, the temperature shoots up to millions of degrees. And it doesn't make any sense because it's farther away from the sun. So maybe we could finally get some answers about this heat phenomenon. The mission is also going to help us understand something called solar wind. The sun is constantly shooting out tiny bits of energy and charged particles into space, like a never-ending breeze of electricity. When this solar wind hits Earth, it can create amazing light shows in the sky called auroras. The more active the sun is, the farther south you can see auroras. Our star follows natural cycles that last about 11 years. The activity goes from low to high and back down to low. Right now, we're in the solar maximum, the peak of the activity cycle. That's why we've spotted beautiful auroras in the most unexpected places in 2024. The downside to it is that the sun's activity can send out bursts of energy and charged particles that can mess up things like radios, satellites, and even GPS. It can be dangerous, especially for astronauts out in space who aren't as protected as we are here on Earth. Humans wouldn't feel the compression of the planet's electromagnetic field because of all the extra radiation, but power grids are really sensitive to it. If we don't act fast, when it happens, the influx of energy will go into power transformers all over the world, disrupt them, and leave big areas without electricity. If this happens during a hurricane or a tornado, when communication is already super important, it could make it much harder for emergency services to communicate and save lives. That's why it's so important to learn to predict this space weather. It's tricky because, unlike most disasters, like earthquakes, floods, and volcanoes, it doesn't leave behind any kind of physical evidence. The only big solar storms we really know about happened in 1859 and 1921. The first one, called the Carrington event, was so wild that it made sparks fly from telegraph wires. The auroras were seen all the way near the equator. Scientists back then were using a special kind of paper that reacted to light to record solar activity. During the Carrington event, the reading from the sun went off the page, literally. Whatever was happening, it was so extreme that we still don't fully understand it. Then, there was the New York Railroad Storm of 1921. It was powerful enough to knock out telegraph systems across the US, Europe, and the Southern Hemisphere. The storm boosted radio transmissions for a bit, making them travel farther than usual. But back then, there weren't nearly as many radios, so it wasn't super helpful. The bigger problem was the electrical grid in the US, which was heavily damaged. Back in 1859 and 1921, people weren't as dependent on tech as we are now. If a storm like that hits today, the consequences could be way more catastrophic. Scientists from New Zealand who study space weather are working on simulations trying to prevent disasters from happening. They say one of the possible options to do it is to study other suns like ours elsewhere in space. If we get data from thousands of stars, not just one, the picture for analysis would be more complete. So far, scientists have launched or plan to launch several other missions in addition to the Parker Solar Probe. Meanwhile, NASA is working on another mission, launching Endurance, robotic moon machinery on steroids. Its main mission will be to collect samples from key lunar locations that will later be retrieved by astronauts from the Artemis program. These samples are spread across the largest impact basin on the moon, separated by hundreds of miles. To do it, Endurance will have to be way more advanced than Perseverance, NASA's current most cutting-edge rover. Endurance will drive roughly 100 times further, drive 10 times faster, and collect roughly 200 times more sample mass. Endurance would also be the first planetary rover to drive at night. And because it will be on the far side of the moon with limited communication to Earth and surface data, it will have to drive autonomously between sample locks and make its own decisions in tough conditions. When it reaches its destination, it's going to switch to a more classic way of doing things. Scientists back on Earth will get involved directly, guiding the rover to explore the sites and collect samples. The teams on Earth will also keep an eye on how the rover is doing by monitoring its telemetry, which is the data it sends back, like its health stats. If they spot any signs that a part is wearing out or something isn't working quite right, they'll tweak the plan to keep things running smoothly. All this will cost huge amounts of money, probably way more than the Viper moon mission that was cancelled after NASA had spent around $450 million on it. While Endurance is in the planning stage, the Blue Ghost lunar lander is already on its way to the moon. Its main mission is research. It will spend 25 days in Earth's orbit, taking measurements and waiting for the right time to fling itself to the moon. After 4 days in transit, Blue Ghost will hang out in lunar orbit for another 16 days to collect more data. Then it will descend to one of the largest basins on the moon and spend 1 lunar day there. It will measure subsurface thermal data, radiation levels, and other important data. At the end of its mission, Blue Ghost will take some final pictures of the lunar sunset. It isn't designed to return back to our planet, so when the night falls, it will do some final work and go offline for good. NASA chose the team of University of Florida aerospace engineers to work on another innovative space project. It will cost $12 million, and its goal will be to improve the way we track changes in tectonic plates and oceans on Earth from space. It will use state-of-the-art sensors that will measure even the tiniest gravitational changes. The data it gets will help scientists monitor droughts, assess groundwater reserves, and better understand changes in sea levels. They expect to launch it around 2027 aboard a SpaceX Falcon 9 rocket. Space is vast, dark, and empty. So, wait, what's that? Is it a sphere? Huh? That looks like something like a whitish soap bubble floating in space. Zoom in. A bit more. Do you see people inside? They look like ants dashing around, doing their own things. Someone is growing food, someone is working in the lab. What kind of a sci-fi fever dream is this? Now, all this might not be as unrealistic as it sounds and looks. Right at this moment, Max Space is working on inflatable space habitats that could make living in space possible and cheap. Their biggest habitat would be as roomy as a sports stadium. They've already shown off their plans, claiming that such habitats could help humanity move off Earth in the future. According to one of the founders, there isn't enough living space in space. And if we don't make it cheaper and much, much bigger, we're not going to get very far in space exploration. As for expandable habitats, they are clever. At first, they're small enough to fit on a rocket, but once they're in space, they inflate to create a much bigger living area. For example, one of such habitats with around 3,500 cubic feet of space would cost way less to make than a traditional metal module of the same size. For comparison, the ISS has about 13,700 cubic feet of living space, so this is a big deal. Similar space habitats already exist. A company called Bigelow Aerospace launched 2 test modules, Genesis 1 and Genesis 2, back in the 2000s. And another module called Beam has been attached to the ISS since 2016. Sadly, Bigelow closed down in 2020. But now, Max Space is taking the tech to the next level. They're using a totally new design to make their habitats expand reliably and on a much larger scale. They're planning to test them in space soon. In 2026, they'll send up a module the size of 2 suitcases on a SpaceX rocket. Once it inflates, it'll have about 700 cubic feet of pressurized space. They've already built a full-size prototype to test on the ground and are now making the real thing for space. While this first one won't support people, it'll have the same strength and shielding powers as future human-rated habitats. Colonies on the Moon and Mars, floating space habitats. Everything seems to be all about space exploration these days. NASA, along with space agencies from Canada, Japan, and Europe, is working on something called the Gateway Program. It is basically a plan to build a space station that will orbit the Moon. Meanwhile, billionaires are busy dreaming up colonies on Mars and Venus and even launching space tourism projects. If these ideas actually work, they'd be our first step towards living in space. But there's one problem. If we want to survive out there long term, we need to figure out how to produce kids in space. Should it be natural ways? Are we going to start using special technologies? Space reproduction is super tricky, and the biggest issues are radiation and gravity. That's where Spaceborne United, a company from the Netherlands, comes in. They're working on solutions for this. They've built a tiny IVF and embryo incubator that's ready to be tested in space. Just recently, they've dropped it from about 12 miles above Earth to see how radiation affects organic materials. The CEO of Spaceborne United has explained that their goal is to figure out if conception and early embryo development can happen in space. If we're serious about settling on Mars or other planets and making those settlements fully independent, we'll need to solve this reproduction issue. For example, Mars has way less gravity than Earth, and no one knows if that's enough for embryos to grow properly. Spaceborne United is starting by studying how partial gravity, like what Mars has, might affect development. It's still early to speak about some results, but at least we've started moving in this direction. Even if we deal with the space kids problem, what about other earthly things, like plants? Photosynthesis has had a massive impact on Earth. When organisms started using sunlight to make energy, it triggered the Great Oxygenation Event. It filled the atmosphere with oxygen, allowed multicellular life to develop, and even formed the ozone layer, which protects us from the sun's harsh UV rays. Thanks to that, life was able to move onto land. But how would plants grow under the light of other stars? Our sun is a G-type star, called a yellow dwarf. It feels like a typical star to us, but it's actually pretty rare. Only about 7 to 8% of stars in our home Milky Way galaxy are like it. And since most stars aren't like our sun, scientists studying habitable planets are focusing on more common types. K-dwarf stars, for example, are smaller than our sun, about 50 to 80% of its mass. But they're more stable and last much longer, up to 70 billion years, compared to the sun's 10 billion years. That's a lot of extra time for life to evolve. Despite this, researchers have often focused on M-dwarfs, aka red dwarfs. They're the most common stars, but they have their own issues, like frequent flares. In a recent study, researchers have simulated the light from a K-dwarf star to see how two photosynthetic organisms would respond. They chose garden cress, a fast-growing plant often used in salads, and cyanobacteria, a tough microorganism that can survive extreme conditions. The goal was to see if photosynthesis would work under K-dwarf light. Then, they put watercress seeds in 3 different conditions: sunlight, simulated K-dwarf light, and no light. The plants under sunlight and K-dwarf light grew similarly, but the seeds under K-dwarf light actually sprouted a bit earlier and had slightly larger leaves. It means that plants could potentially thrive under K-dwarf light just as well as they do under sunlight. So, K-dwarf stars seem like a great option for finding habitable planets. Unlike M-dwarfs, they don't have intense flares that could harm life, and their habitable zones are far enough out that planets wouldn't get stuck in tidal locking, where one side of the planet always faces the star. K-dwarfs also become habitable sooner in their lifetimes because their harmful radiation drops off faster than that of M-dwarfs. But how about this? What if life doesn't actually need planets to survive? That's the idea 2 scientists from the University of Edinburgh want you to consider. We've always assumed planets are crucial for life because they provide the right conditions: liquid water, temperatures and pressures to keep it liquid, and protection from harmful radiation. But what if life itself could create those conditions in space? The researchers suggest that ecosystems could generate and maintain the conditions they need without needing a planet. Life could create barriers and structures to keep water liquid, let in light for photosynthesis, block harmful UV rays, and even maintain the right pressure and temperature. And all of this in space, far from any planet. These barriers could work in regions between 1 and 5 astronomical units from the Sun, which includes areas closer to Earth and Mars. Gravity and planets might not always be necessary for stable environments. Biological systems might be able to do the job themselves. Earth is a perfect habitat for life, not only because it has water and a protective atmosphere. It's also an interconnected system where energy from the Sun powers everything. Essential elements like carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur cycle through the planet thanks to such processes as volcanism and plate tectonics. Outside Earth, things get trickier. Take the icy moons in our solar system, for example. They might have warm, salty oceans beneath their surfaces, but do those moons have nutrient cycles like Earth? And can they keep water liquid or maintain an atmosphere? These small, cold worlds don't get much energy from the Sun, have no way to hold on to their atmospheres, and are exposed to harmful UV radiation and cosmic rays. For life to survive beyond Earth, it would need to adapt to these challenges or modify its environment. And if their idea is true, then perhaps life doesn't just adapt to its environment. It could also create entirely new ones.
You're standing next to a huge floor-to-ceiling window of the spaceship/wandering city you've been calling your home for a dozen years, along with a few hundred other people. You're watching a fascinating object nearing your spaceship, wondering if it'll bring an end to this journey and your life. It looks like an asteroid, but acts like a comet, moving as if something is pushing it. Can it be the engine created by another space civilization? Are you doomed, or are you about to have contact with a different kind of intelligence? Now, let's leave this post-apocalyptic fantasy and take a closer look at these space invaders called dark comets. The most intriguing question is obviously, what makes them move? Most likely it's some gas or material escaping from the surface of these space objects. Interestingly, until recently, no one has even been sure they existed. The first dark comet was discovered just a few years ago, and since then, researchers have identified 14 of them, including 7 new ones found just recently. The story of dark comets began in 2016, when scientists noticed something strange about an asteroid called 2003 RM. Its orbit wasn't quite what they expected. It had shifted slightly, and no one could explain that shift by typical asteroid behavior, when they received tiny pushes caused by sunlight heating an asteroid unevenly. Instead, the movement suggested that 2003 RM might have been releasing material, something comets often do. But there was a catch. The thing didn't look like a comet. There was no tail, no visible gas cloud. It was just a tiny dot of light, like a regular asteroid. At first, scientists thought 2003 RM was just a one-off mystery. But in 2017, a telescope spotted another strange object, this one from outside our solar system. It was Oumuamua. It too looked like an asteroid, but had a path that changed as if gas were escaping from it. The similarities between Oumuamua and 2003 RM made researchers think there might be more of such odd objects out there. By 2023, 7 more had been discovered in our solar system. These discoveries were enough to give this new type of object the name of dark comets. Now, scientists have enough data to start noticing patterns and learning more about their characteristics. And so, they have identified 2 main groups of dark comets. The first group, called outer dark comets, is larger, with sizes ranging from hundreds of feet to even more. They follow long elliptical orbits, similar to traditional comets that come from regions near Jupiter. The second group, inner dark comets, is smaller, usually tens of feet across. These comets move in almost circular orbits and stay closer to the Sun, near planets like Earth, Venus, and Mars. The main question these days is, where do dark comets come from? Can they be the remnants of larger bodies that broke apart? These space bodies could help us understand the history of the solar system. What if they had delivered the ingredients for life to early Earth? Once we study dark comets better, we might figure out if they contain materials like ice or organic compounds. And indeed, some researchers are sure that dark comets may contain or once have contained ice and played a big role in bringing water to Earth. According to a couple of studies, Some asteroids in the asteroid belt, a region between Mars and Jupiter filled with rocky debris, might have ice beneath their surfaces, and this ice from the asteroid belt could have traveled into near-Earth space. In other words, it could be a pathway for water to reach our planet. So far, no one is saying that dark comets definitely brought water to Earth, but they might be another mechanism for moving ice from one part of the solar system to another. The study also hints at a connection between dark comets and a group known as Jupiter family comets. These are comets whose orbits are strongly influenced by the gravity of Jupiter, often pulling them inward toward the Sun. This connection makes it even more difficult to understand where dark comets come from and how they behave. Now, let's take a closer look at the differences between asteroids and comets. Traditional asteroids are rocky bodies that orbit relatively close to the Sun, typically within the ice line. This region is so close to the Sun that any ice on an asteroid surface would turn directly from a solid into a gas, leaving behind only rock. Comets, in turn, are icy bodies that form farther from the Sun. When they approach the inner solar system, their ice starts turning from a solid to a gas tube, creating a visible cloud called a coma or a tail while releasing dust and gas. Dark comets blur these definitions. They appear as rocky asteroid objects without a coma or tail, but they have behavior typical of comets, and that's small non-gravitational accelerations. These accelerations occur when ice turns into gas, giving the object a slight push. After analyzing 7 known dark comets, astronomers estimated that between 0.5% and 60% of all near-Earth objects might belong to this mysterious category. And since dark comets likely come from the asteroid belt, ice is likely to exist even in the regions of the belt previously thought to be too warm. Now, near-Earth objects, like dark comets, don't stay in the same orbit forever. The near-Earth environment is unstable, and objects typically remain there for about 10 million years. Since the solar system is over 4.5 billion years old, this means that new near-Earth objects must constantly replace those that are lost. Now, astronomers have used computer models to simulate the movement of objects under the influence of non-gravitational accelerations. They've traced the paths of these objects over a span of 100,000 years and discovered that many ended up in the same regions where we find dark comets today. Now, do you remember that space rock 2003 RM, which was the first to be called a dark comet? Well, it provided a particularly interesting clue. Its elliptical orbit brings it close to Earth, then out near Jupiter, before returning to Earth again. This trajectory matches what scientists would expect from a Jupiter family comet, an object that was likely knocked inward from its original orbit. Most of the other dark comets studied, however, seem to have come from the inner regions of the asteroid belt, closer to Mars. Dark comets are often small and spin rapidly. Astronomers often describe them as dirty ice cubes, all because these objects are a mix of rock and ice, and when they cross the ice line, their ice begins to turn into gas. This process not only causes those small non-gravitational accelerations, but also increases their spin rate. And the faster these objects spin, the easier they can break apart into smaller fragments. The pieces that break off also have ice, and as they spin faster and faster, they break into even smaller pieces. This process continues until you're left with very small, fast-spinning objects. This cycle of fragmentation helps explain why dark comets are often so tiny, but it could also mean there are more of them than we currently know about. The dark comet research provides new insights into the distribution of ice in the solar system and its potential pathways into the near-Earth environment. It also raises intriguing questions. For example, how much ice remains hidden in the asteroid belt? Or could dark comets have played a role in delivering water or organic materials to Earth? One of the most important points is that dark comets may represent a significant part of near-Earth objects. If it turns out to be true, it could mean that our understanding of the population of near-Earth objects and their potential risks for our planet is far from complete. The processes shaping dark comets, from sublimation to fragmentation, could be a major factor in the evolution of icy bodies throughout the solar system. Luckily, these days, scientists have an opportunity to combine advanced modeling with observations which can eventually shed light on that very elusive class of objects that